Now, with this discussion, can we find the answer? If I say this is the radius of the moon, and this is the radius of its image, then I see that this is one triangle and this is the second triangle, and both the triangles are similar, which means I can say that the radius of moon upon radius of, if I call this as capital D, then it will be, note it down please. So I can say that the radius of the image is radius of moon into F by D. Now, if you can substitute the values and find the answer. Clear? The answer is 6.9 centimeters. 6.8 something, 6.9 centimeters में meters में किस में आ रहा है? Because this focal length is also meters. ठीक है. Perfect. This is one thing which I wanted to discuss in reflection. Now, have we discussed the vector equation of laws of reflection? No, we haven't. Okay. एक चीज मुझे ये बतानी है आपको. I'll let you know. And then I'll take one problem taking reflection and collisions into account. Imagine you can have mechanics collisions in reflection also. Like first of all, the vector form of the laws of reflection. Suppose we have a question like this in the entrance exam, that there is an incident ray or there is an incident beam whose direction or which can be represented, that ray or a beam can be represented by a vector which is, say, I cap plus 2j cap plus 3k cap. This is the vector equation of the ray or the beam. Ray I can't isolate, so I can call it a beam also. Now, the question is that this beam or this ray strikes a plane mirror, and the plane mirror is kept, in the XZ plane. So is asking you, the question is, what will be the unit vector along the reflected ray? What will be? Find a unit vector in the direction of reflected ray. That's the question. Right? क्या कह रहे हो? वो इंसिडेंट रे का यूनिट वेक्टर होगा. हमको रिफ्लेक्टेड रे का यूनिट वेक्टर निकालना है. कितना मुश्किल सवाल था ना वो तो, कि एक वेक्टर दिया है, उसकी डायरेक्शन निकालनी है. ठीक है. नाउ I can tell you this answer by common sense also. But let me first explain you the mathematical way to approach this problem. एक situation देखिए आप. Say it's a plane mirror and is placed in the XZ plane. Therefore, the normal is along y-axis or j cap. Not specific for this question. In a general case, I can call it n cap. Now, there is an incident ray which is striking the mirror. I think you can close this. देखिए इसको बंद करके देखना. नहीं. Okay. ठीक है. Now, suppose this is the incident ray. I call it E1, the vector along the incident ray. Right? And I want to calculate the unit vector along. So I can take this as the unit vector also. Okay. Suppose this makes an angle I, or the angle of incidence is I. This is going to be the reflected ray. Let me call it E2 cap. I know that this angle also will be I. Yes? Perfect. Now, if I extend this, and draw a line parallel to this line, then I can say that this vector plus this vector equals this vector. Simple vector triangle law vector addition. Let me call this as, say, AB, the length of this vector as AB, because the direction is n cap. Now, can I say that E1 cap plus AB n cap is E2 cap? That means to calculate E2 cap, I need AB. Yes? This is the length AB. Perfect. Now, if I say find the dot product of E1 dot n cap, क्या लिखेंगे आप? आप लिखेंगे E1 magnitude n into cos. I नहीं है, ये E1 cap है और ये n cap है. So that means this is the angle what I need. Angle between the two vectors is the angle between its two tails or two heads, and not head and tail. If you want to take this angle, this will become the head. And for this vector, this becomes the tail. So I have to extend this, make it a tail. This is the tail, and this is the angle which I want. How much is this angle? 180 minus I. Now, this can be written as, this is one, unity cos. So I'm saying that E1 dot n is actually minus cos I. I want AB. I have still not entered AB, but there is in a different way. I've entered this triangle through cos I. If I wish to calculate the length of AB, and if I know I, then I can use the cosine rule. What is cos I equal to in this case? E1? रुक तो जा, यहाँ कोई perpendicular थोड़ी है. Cosine rule पता है ना? If I have to find cos of this angle, this is this square plus this square minus this square into do 2 times this into this. ये पता है ना? है? ये तो basic cosine rule है. जैसे दो rules होते हैं. One is a sine rule and the other is a cosine rule. Cosine rule में क्या होता है? बता ही देता हूँ चलो आपको. If I have to find cos of this angle, then it is equal to इसके जो adjacent sides हैं उनका square. तो this square plus minus सामने वाला E2 का square upon 2 times note it down please. ठीक है? And if I solve this, what is cos I equal to? This is 1 plus minus and I get AB as and if I take these two equations, then I can say that my AB and if I substitute the value of AB here, then E2 cap is E1 cap. This is your vector form of laws of reflection. This is what is called the vector form of laws of reflection. Actually, you can use this result in coordinate geometry and vectors also. And in mathematics, if they ask you that this is the direction of a ray or a line, it represents a direction, it strikes a surface, and they give you equation of the surface, and they ask you what will be the reflected light or reflected, the equation of the reflected ray, or if the angle it makes with the normal is equal to the angle it makes, the reflected ray makes an angle, same angle. So what will be the equation? So you can actually use this. Have you understood this completely? Fantastic. Now we can go back to that question where I gave you E1 vector as I cap plus 2j cap plus 3k cap, and hits a mirror which is placed in the YZ plane. Right? So the first thing is you need the cap. You need the unit vector. So you divide this by its, कितना हो गया? So this becomes even cap. Now, since the mirror is in the YZ plane, therefore the normal will be along so that means n cap becomes I cap. Fill in the blanks. जी क्या आंसर आ रहा है? What is E2 cap? है ना? पुराने वाली पीपीटी है, निकालो उसमें से तो this topic or previous topic. Okay. हो जाएगा. Done. What is the value? Okay. Very good. बड़ी खुशी की बात है. Oh, you are rocking, girls. This is the answer. If I don't see, there are two ways to approach a problem in life. One is obviously a regular way. This is a regular way. And the other way is slight conceptual clarity. अगर हो थोड़ी सी. Yes. The ray optics is based on the concept of Newton's corpuscular theory. I told you in the first class, which means that when I'm saying this is the direction of the incident ray, it actually means that there are infinite elastic balls striking a frictionless surface. Now tell me, when I allow a ball to fall like this, in which direction does it move after bouncing back? Back. सही है. That means if this is y-axis, so this is say minus j cap, this becomes and suppose I say that there is a ball which doesn't fall vertically but which comes with a certain angle, and say this is again y-axis. What will happen? Suppose this has a component, this is vy, and this component is say vx. So once it hits the surface, the ball, the elastic collision happens. This will become and this will continue to remain. That means only that component changes which is along the normal to the surface. In this case, the surface is a plane mirror, and the normal to the surface, the YZ plane, is the x-axis. So it is going to be the component which is along the x-axis, which is going to change its direction. So initially it was plus I cap, 2j cap, 3k cap. And since the normal is along x-axis, therefore only this will change its direction. So this directly becomes perfect. Now, to an extent, that if this question comes like this, that this is a unit vector along the incident ray, it first strikes the YZ plane. The mirror is in the YZ plane. Then it strikes the XZ plane. And then it strikes the XY plane. All reflections. Absolutely. So आप ये बोलते हो ना कि अगर there are three, in this case, if there are three consecutive reflections like this, then the ray moves anti-parallel, which means this will be minus I cap. So this is one concept I wanted to tell you. Okay, clear on this? Absolutely. Okay, now let me take the next question. I told you I'll take another question and then we'll move to refraction. Fantastic. So now you have two beautiful concave mirrors. They are on a stand. It's a stand, and you have two concave mirrors which are facing in the opposite direction. The mass of this stand is small m. There are two objects, m and m. Their masses are also m and m. Right now, this mass is at rest. This mirror is also at rest. And this block or this mass starts moving towards the mirror with the velocity v. Perfect. At t equals 0, when we start this operation, this mass, the distance of this mass from this mirror is 2r. The distance of this mass from the mirror is also 2r, where r is the radius of curvature of these mirrors. Okay? First class? Now what happens? Because this mass has a velocity v, he's asking you, obviously this mass at some time will strike this, collision will happen, or this strikes this, collision will happen. All these collisions are elastic in nature, and this surface is absolutely frictionless surface. Now what he's asking you is that taking the original positions of the mirror stand, I mean, we take this as x equals 0, this is x equals 0, find the position of the images of A and B. A ka image, B ka image at 3 different times. Now the first time is r by v. So he says that after a time r by v, what will be the position of the image of A and B with respect to the concave mirrors. This is a good question, I would say, because it relates to mechanics and optics. And this becomes important also. Why I'm discussing this question is, this allows you to think in both the directions. See, when you study optics, there is only one path you travel. But on the day of examination, you would have to be knowing everything. You should know mechanics, you should know optics, you should know electricity, all the topics. So you can have a problem, you can get a question which relates to more than one concept. So this question will allow you to think, and then tell me. When you do this, just raise your hand, and then I'll come to you. The block B moves towards the mirror at a speed v. Find the position of the images of A and B at time t r by v. I think the first part is absolutely simple. What was the position of B at t equals 0 with respect to the mirror? 2r. Now, when this mirror moves with a velocity speed v, in time r by v, how much distance will it travel? R. Time is r by v. C पे पहुंच जाएगा तो चुप ही हो जा. क्यों? है हाँ. So 2r say it will reach r. Will it change a position of A? Will the position of A change with respect to the mirror? No. Will the position of the mirror change with respect to ground? No. अभी तो strike हुआ ही नहीं है. अभी तो object ने mirror को strike किया ही नहीं है. So the position of A will not change. The position of the mirror will not change. What will change? Of the object. If I call B as the object, what will be the position of the object B after time r by v? The center of curvature. It will be at r. So अब अगर मैं आपसे पूछूं कि B object, if it is at r, where will the image of this object be formed? At r. So you know the first answer. So you know that after t equals r by v, the image of B will be at the position where the object is. लिखिए. Yeah, have you understood the question? And what about A? Where will the image of A be formed? You remember that formula? For concave mirrors. Yeah. I gave you a formula that xi is right. If I talk about this mirror and this as the object. So this is the situation. This is C. And here the object is kept. I told you to take this as plus x, remember? जो इसका silvered portion है, जो polished surface है, उसको आप positive x लेंगे. So if I substitute and this, as far as this is concerned, the focal length here will be negative. It will be minus. So x naught is minus 2r. F is minus x naught again. So if you solve this, what is the answer? इतना देर minus that means in the first case, when the time is r by v, this object would have traveled a distance L. R, the image would be formed here only. As far as this is concerned, this distance is 2r, and in time r by v, this object and this mirror would have not moved at all, right? And the image will be formed, if this is 2r, if I divide it into 3 parts, so the image will be formed at 2r by 3. On the left hand side, it's negative, it's on the left hand side. And if this is 2r and this is r, and if I say 2r by 3, so that means somewhere between the focus and the center of curvature. The first part is done. This is simple, nothing is happening. Let's move on to the second situation. The second situation is that the whole thing restarts. We are in the restart mode. सब कुछ हमने restart कर दिया. And now I want to know what happens to the positions of the image after a time 3r by v. This is what you have to think. सोच के बताइए. What would happen after 3r by v? Only B is moving. A is fixed. The mirror is fixed as on now. टू आर बी पर इसको हिट करेगा. Velocities will get interchanged. This will start moving. This will be at origin. 2r distance के बाद origin पर है, and this will start moving with velocity. And when it travels with velocity v, this distance is 2r. So where will this mirror be? At a distance r from this object. ऐसा सोचोगे ना? ये देखो जोशी tutorials. मेरा घर. कितने regular. यहाँ भी ना. यहाँ भी ये मचा हुआ है. 1 2 3 राइट. जी बताइए. Does this question allow you to think? That means it's a good question. हो रहा है? हो गया? Right, girls. Initially, what is this distance? And what is this distance? Fantastic. I want what happens after t equals. Confuse ही कर देती है. ठीक है? The mass is m, this mass is also m, and this mass is m. This is the situation at t equals 0. Now, at t equals, after t equals 2r by v, this object would have reached here, and collision would have happened. Pure elastic collision happened. The masses are similar. So velocities will get interchanged, right? So after this time, this will start moving with V, and this mass would reach here, and its velocity will become perfect. This now between 2r by v and 3r by v, this mirror would have moved here. Another distance, how much? R by v. Oh, sorry, distance r. So which means now the situation is that this is B. This is the mirror. Yeah. And that's the perfect. This distance is, and this distance also is. Wow. Bana. Understood? Not difficult at all, but allows you to think. Next year, इस साल, अगले साल, next year, you will be in IITs. Written your first semesters, and you would have got your result. And will say it is 9.8. कितना मजा आने वाला है ना? So when you feel this, when you get this excitement, it helps you to, it motivates you to solve problems faster. Yeah, are we clear? So that's the object, that's the mirror. It is at the center of curvature, so image will be formed here. For this object and this mirror, this is center of curvature. That means image will be formed here, है ना? तो A का image यही बनेगा, B का image यही बनेगा. But if I see the coordinates, he wants me to tell you the coordinates, then the image of B will be at origin, and the image of A will be at minus 2r. If this is positive x-axis, this is minus. Perfect. Now, the third one. T equals 5r by v. Again, the system has reached here. चलो अब system को यहाँ मान लेते हैं. We have already reached here. Where have we reached? What will happen now? Between 3r by 5 and 4r by 5, the mirror would have reached here. If I see the next situation, this is T equals 2r by 5. This is equals 3r by 5. V, sorry, I'm so sorry. And this is T equals 4r by v. So I've reached here. The mirror has also reached here. A is here and B is still here. Now what will happen? After this, they'll collide. And what will happen after the collision? The velocities will again get. That means at this instant, what will happen? The mirror comes to, and this object starts moving towards left or right? Towards left with a velocity. And between 4r by v and 5r by v, how much distance will it travel? So at t equals 5r by v, this is A, this is the mirror, and here is B. B तो move कर नहीं रहा है ना जी? Perfect. What is this distance equal to? And this is the mirror. So with respect to B, I'm at a distance 2r. And with respect to the mirror, A is at a distance r. So for A, the image will be formed. So the image of A will be here. Yes or no? So this is IA. And what about IB? 2r by 3. अभी निकाला था हमने. It will be formed between 2r by 3. At 2r by 3. Note it down, please. आज भाई अब तेरे को एक्सप्लेन करना है. Put. Who will take the lead to explain this question? Miss Haryana, उठे जरा. This is the best way to learn. This is the best way to learn.
Firstly, this M was rest, and first in the starting, this B was at rest and this mirror was rest. Then it B start with moving with velocity V towards mirror, and and distance between them is 2r. Then it collides with mirror, and the B comes at rest.
How much time does it collide?
After time
2
r by V.
ऐसे बोलो.
After time 2r by V, B will come at rest and mirror will start moving with velocity V as the collision is elastic. And here mirror will come in motion and with velocity V. After time 3r by V, it will
After a time r
3
by v after 2r by v. No?
after time 3r by V, it will reach here, and the distance between A and mirror is r, and distance between B and mirror is r. So the image of B will form at r, and image of A will form at r. Then after time 3r by V, ये हो गया. After time 4r by V, the mirror will reach at A, and mirror will come at rest, and A will start moving with velocity V. A will move with velocity V, and after time 5r by V, A will reach here, and the distance between mirror and A is r, and the distance between B and mirror is 2r. And we found out here that
If the distance of the
object and the mirror is 2r, then time is position of the mirror is 2r by 3.
and for what about A?
And for A, the distance between them is r, and so the image will form at r.
Amazing. Please clap for her. And you are scared when you will perform. Have you understood this question completely? See, it is constant velocity. Straight line. See, the issue is you want to find position time graph. There are two things. In this case, velocity and time is dependence are we know about. We also know the dependence of xi with x naught, which is hyperbolic. Xi to x naught is hyperbolic, but x naught to time is a straight line. Will be imagined. Did you enjoy the question? Extremely impressive. You want to do another question on collisions? हो जाए दो हाथ. चलो. Next question. Wow. So you have a gun, you have a bullet, and you have a mirror. North India. Welcome to North India. You have a gun of mass M. It fires a bullet of mass small m with a horizontal speed v. The gun here, the bullet, the mass of the gun is capital M, the mass of the bullet is small m, and the bullet leaves the gun with a speed v. Now this gun is fitted with a concave mirror. Okay, this is the bullet, that's the barrel, and on this is a concave mirror. The polished side is this. The mirror of focal length f facing towards the receding bullet. Obviously, the bullet इधर जाएगी ना, तो उसी को face कर रहा है. Find the speed of separation of the bullet and the image just after the gun was fired. Like in plane mirrors, we had discussed problems where a plane mirror is moving with a certain velocity. An object is moving with a certain velocity. Then what is the velocity of the image? It's a similar question. Instead of plane mirror, you have a concave mirror. बनाइए. This velocity v is with respect to ground. And this line is also very interesting. Just after the gun was fired. See, when I say the gun and the mirror are fitting together, and mass of the mirror is very, very small as compared to the gun. So practically, I take this gun and the mirror as one system. Gun है ना, ये mirror है, ये bullet है. Now the mass, इसमें mass of the mirror is not known to us. So maybe we are assuming that the mass of this mirror is very, very small. Therefore, the mass of the gun and the mirror is capital M. Yeah. And this is the bullet. which has been fired with the velocity v. And this velocity is with respect to ground. Now, first of all, can I apply the law of conservation of linear momentum? I can apply that. Because the net force acting on the gun and the bullet is 0. Action reaction. So I can always say that m into v, and this will be in this direction. So I get the velocity of the mirror, I can call it the mirror, and this is the bullet, as in optics. All the distances which are measured, the object distances are measured from the, are always measured from the, with respect to the mirror. So the mirror has to be at, therefore, can I find the velocity of the bullet? Bullet is the object, right? With respect to mirror. वो कितना हो जाएगा? So this will be which will be so that means this is the velocity of the bullet with respect to the mirror. So that means this velocity becomes now the interesting part in this question is, he says, just at that instant when the bullet is fired. So at that instant, the bullet will be here only at the pole. And when the object is at the pole, then the image is also formed at the pole. Therefore, if the velocity of the bullet with respect to mirror at the pole is this, then the velocity of its image will also be same. Yes or no? And the velocities of the object and the image will be in the opposite direction, which means answer to this question is the speed of separation will be 2 times this will be the velocity of the image with respect to the bullet. Understood? Enjoyed? Okay, done. Okay. So now finally, I'm convinced that we can move on to refraction. Now this is the right time to enter refraction. So I would say refraction now till now, when we studied reflection through plane mirrors or through plane surfaces or reflection through spherical surfaces, we did not allow the light to pass glass. We did not allow the incident beam to change its medium. We did not allow the incident beam to change its velocity. But if I don't polish the surface and allow, see, what you do is, when you polish a surface, you're basically making that surface opaque. आप आने का रास्ता ही बंद कर रहे हो. So air से glass के medium में entrance ही नहीं हुई. The ray did not move, did not change its medium from air to glass. But if I want that to happen, then I will not make the surface opaque and allow the light to enter a different medium. What happens when an electromagnetic wave or a light beam enters, changes its medium? The speed changes. That means if I have to travel in air, say a distance from this point to this point, I want to travel this distance. I know this distance. I know my velocity is velocity of light. So I can calculate the time it takes me to reach from here to here with velocity of light. Now, when I'm moving from this point to this point, I'm in air. I know my time. I take another distance, which is same as this, but my velocity changes. And I have to cover this distance, say with a lesser velocity. I'll take more time. Now, what happens is that a ray travels in air, takes a time t1. It travels in another medium, takes time t2. Now, which means the ray will not take, if there are two rays in a beam which are traveling together, but say two rays travel in vacuum, and there is a situation when one ray travels in vacuum and the other in a medium, then the way that ray moves, its orientation will change. The ray will start bending. Yes? आप इसको ऐसे समझिए. If I say that this time and this time has to be same, and my velocities are different, so I'll travel different distances. So how do you travel different distances? By changing the path. But if I travel a distance x like this, and if I travel like this, now this distance is going to be more than this distance. So if I fix up two times, I say, listen, you have to travel with two different velocities in the same time. Then you will tell me, sir, then I'm going to travel different distances. So how do you travel different distances? By having different trajectories. And how do you have different trajectories? By traveling two different paths. Now this is exactly what happens, and this is why a ray bends when it enters from one medium to the other. So refraction is a study where we will study how a light beam ray bends when it travels from a medium to another medium. And to help us to find out, to locate that how the ray would finally travel in different medium, came a gentleman, Snell, and gave a very beautiful Snell's law. Now again, Snell's referred to Fermat. I told you the Fermat's principle, and referred and said, hello, whether the ray is traveling in the same medium or it is traveling in some other medium, the time that ray has to take in either of the mediums has to be optimum. So even when a ray passes through on the medium, the time a ray should take should again be optimum. On the basis of that, Snell's formulated the theory, formulated a result. Like if you remember correctly, if I were to use Fermat's principle, if this medium is mu1 and this is mu2, now you know how do you, now again there's a problem. Now how do I know that if I'm traveling in a medium, I'm traveling with velocity of light, I'm traveling in a different medium, I'm traveling with a certain different velocity. Now which is a term which relates to velocities changes or the ratio of velocity? Is refractive index. So a medium is defined by its refractive index. And the refractive index is denoted with by a term called mu, and mu is practically C by V. So velocity of light in vacuum upon velocity of light in that medium. So if I wish to calculate velocity of light in a medium, and if I know the refractive index of that medium, I can find out, because I know the velocity of light in vacuum is 3 into 10 to the power. Okay. So this is mu1, this is mu2. Now this is an interface. Now interface is a medium which divides two different mediums. So whether this divides this complete medium into mu1 and mu2. Suppose a ray of light comes, falls on this refractive surface, and say this angle of incidence is I. So that means this is the source. Source S1 or source S. Its distance from the surface is constant. Let me take this as H1. The ray refracts. it refracts to a certain angle r. I set a receiver here. The distance that receiver has, the perpendicular distance from the surface, says h2. Oh God, medium change करना पड़ेगा. हमने तो रिफ्लेक्शन करा दिया और तुम हाँ करते रहते हो. ये नहीं कि सर प्लीज रिफ्रैक्ट कराओ, तो करा देता हूं. करा दिया. So here is a receiver, and this angle is the angle of refraction. I draw a perpendicular here. This is h2. Now the distance between the two perpendiculars will be constant, so I take this as d. And this distance is x. So this distance becomes d minus x. Now, according to Fermat, this time plus this time has to be optimal. So please find out time from here to here. Time is distance upon velocity. So distance will be this is the total time. To find whether this time is optimum, maximum, or minimum, I'll differentiate dt by and put equal to. Try to differentiate this function, please. Very good. Excellent. क्या है? Yeah. If this is I, this will also be I. If this is R, then this will also be R. Just check out on this. What is this? X by this distance. What is this? Sine? वो क्या? Wow. So this this is how Snell's law is proved. Again, the basic thing is that a ray of light takes optimum time for a reflection or a refraction. The basic idea is that the time a ray should take from an object to make an image should be optimum time. Clear? Pakka? I. Sin I कितना होगा? Perfect. Now, on similar grounds, let's prove the vector form of laws of refraction. And the situation will be something like this, that there are two mediums separated by an interface, and this is the incident ray. That's the normal. This is the unit vector along the incident ray. This is I. That's the refracted unit vector, or this is the direction of refracted ray. And this is the angle of refraction. And I want to find the vector form, and this is the normal. Now, we have found out that mu1 sin I is mu2 sin R. Can I do one thing? In a very intelligent way, if I ask you the value of E1 cross n cap, the E1 cap cross n cap, क्या लिखोगे? क्या चाहिए आपको? What is the magnitude? So what is sin I equal to? लिखो. Yeah. Are we clear? You have your module. Just show me. I want to take a question from Come in IIT. इसमें J सेक्शन कहां पर है? Four 117. Please, may I was just thinking of a J section. ये टॉपिक वाइज J सेक्शन नहीं है? है? सेम ही है। चलो, I'll take a question. लिखना. Make the same diagram. Same thing. Take a mu1 as root 2. Mu1 as root 2, under root 2. And mu2 as root 3. The interface is YZ plane. The interface is the YZ plane. And suppose I take the incident unit vector as say I cap plus 2j cap plus 3k cap. And I ask you to find out the unit vector along the refracted ray. Okay, chalo, I got the correct question. This came in J entrance exam. आप incident vector को change कर लो. Change the incident vector and write 6 root 3 I cap. I'll change the question. आपने क्या लिया refractive index root 2 और नीचे root 3. यहां तक ठीक है, perfect. Now let me take the incident vector as 6 root 3 I cap plus 8 root 3 j cap and minus 10 k cap. This plane is XY plane. The plane of the interface is the XY plane. And we have to find the unit vector along the refracted ray. So your n cap is k cap. And that's a result we can use. mu1 is root 2. I mean, maybe you can assume that E2 vector and since we have to find E2 cap, a unit vector, that means we can say now solve it. It's a simple vector equation. You have a left hand and a right hand side, equate them. What is the magnitude of this? 20. I have to find a unit vector, na? 20, na? So what do I write? Plus, minus, upon, cross, and this is equal to yeah, right. If you are comparing the left and the right hand side, what is the value of A, B, and C? A कितना आ रहा है? नहीं. 2 by 20. 20 भी आएगा ना, मैग्नीट्यूड भी तो आएगा. Yeah. What is the value of A? B? Oh, very good. And C? You will have a plus minus, है ना? दोनों आएंगे ना? Plus and minus कितना आ रहा है? 10, but root 2 by 20. But now since ऊपर वाला axis was plus Z cap, K cap, तो नीचे वाला क्या होगा? Minus K cap. And after refraction, the ray will come down. So therefore, I'll use a minus. कितना था? 10. So your final vector is 6 root 2 I cap, 8 root 2 J cap, K cap pi. So this is your refracted unit vector. Yes, मजा आ गया? Convinced? Any doubt? काफी improvement है. You're showing good improvement. Done. Perfect. Any doubts? Are you getting confidence in optics? How's your performance in the tests, by the way? Like, positions क्या रहती हैं? How many students write these exams regularly? I mean, across India, how many students? Around 300. Achha, what is your rank on an average? किस जोन में रहते हो आप? Your rank, best rank was 4. Very good. आपकी best rank क्या रही है? देखते नहीं हो? 40s में कुछ नहीं. 13. Exams को, do you take your exam seriously? It's just for the heck of it. Take exams extremely seriously. In a way, that is the only way you will come to know where are you doing mistakes. या आपकी गलतियां कहाँ करते हो? ये exams के अलावा और कहीं पता चलेगा ही नहीं. Take your exam seriously. Now, coming to refraction. अब यहाँ से we are going to go in a magical world. Magical world as in, I'll tell you a few things which will ease out optics pressure absolutely to zero. कुछ नहीं बचेगा. उसके लिए I'll discuss one interesting formula. ध्यान सुनिएगा. Suppose I take, we are not going to use any sign convention, no lens maker, nothing, no formula. एक basic concept को understand करिए and then we'll take it further. For example, I take a curved surface, a spherical surface whose radius of curvature is r. This is the principal axis. The refractive index here is mu1 and the refractive index here is mu2. I keep an object here in mu1. So when I say that I'm keeping the object here, it means it has to be real. जब मैं कह रहा हूं मैं रख रहा हूं तो real ही हो सकता है, virtual तो हो नहीं सकता वो, तो real ही है. That means it's a real object. Say this distance is x. Now the image could be formed in this medium or could be formed in this medium. Let's say the image is formed here. I mean, as I said, this object is real because it is placed. Now, how do you find whether the image is real or virtual? Interesting, no? If the medium of the object and the image is same, virtual image. And if the medium of the image is different from the medium of the object, real. But the object yahan or image yahan, real object, real image. But if the object is in this medium and the image somehow is also in this medium, then we will call that as virtual. This is one way to identify. There are other ways to identify also, that which I'll tell you. Say we say that the distance of the image from the pole is y. I said this is a real object. The other way to explain that this is a real object is that rays from this object will diverge as they move towards the refracting surface. Now, I'll define a term called power of a refracting surface. You wonder that what is power? And do we have power only for refracting surface or do we have power for reflecting surface also? Now, power is basically called the converging tendency of a surface, whether reflecting or a refracting. Meaning thereby, suppose this is a surface and a ray is coming parallel to the surface. After this, if I'm talking about refraction, the ray instead of going like this, goes like this. So that means the ray has been converged. The ray this surface has a converging tendency, and I say power is positive. So when I say power is positive, it means the ray gets converged. Now this can also happen in a concave mirror. ये concave mirror है. ये ray of light आया. ऐसे आ जाता है ना reflect होने के बाद. Focus पे converge करता है. So that means concave mirror also has a positive power. If you talk about lenses, in convex lenses, we haven't done them, but class 10th में इतना पढ़ा होगा आपने. Convex lens में क्या होता है? अच्छा, by the way, Which is this lens? Convex or concave? This is, we'll prove it is concave in some time. ठीक है, हाँ करेंगे. शक्ल पे थोड़ी जाना है यार, विचारों पर जाना है. Not the face but the soul. It looks like a convex. It'll do concave. वो काम करेगा जो concave lens करता है. Anyway, but if I were to say that a convex lens, I'm saying that this might not be a convex lens, but convex lens will be a convex lens. ये नहीं है, कोई तो है. तो जो भी है, जो convex है, उसकी power भी positive होती है. So power of a concave mirror and of a convex lens is positive because they both converge the incident beam, and power of a concave lens or a convex mirror is negative because it diverges. So when I say power is positive, it means this surface has a converging tendency. So a power positive is convergence, a power negative is divergence. Anyway, now how do you define power of a refracting surface? Like for example, this is a refracting surface. Its radius of curvature is r. There is a refractive medium. There is a medium which has a refractive index mu on the left, and the right is. How do I find the power? Now I'll define power for you. Now power denoted by P is the refractive index of the concave side, which is minus the refractive index of the convex side, which is by R. लिखो. Heavy वाला नहीं, slightly heavier. Clear? So this is my definition of power, and my definition of power for a refracting surface is its mu concave minus mu convex upon radius of curvature r. Perfect. Say if I say, and I told you that either power can be positive, or it can be negative, or it can be 0. This means converging tendency of the surface. This means, and this means nothing. Nothing. It doesn't converge, it doesn't diverge. ये हो गया एक single surface के लिए. Like for example, if I say this is a refracting surface, I mean this refractive index is 2 and this is 3, and radius of curvature is 1 meter. Find the power of this surface. So your answer will be 2 minus 3 by 1, which is, instead, for the same shape, if I say refractive index is 3 and this is 2 and r is 1 meter, so your power will become same shape, 2 different powers, diverging, converging. R negative kabhi nahi lena, R hamesha positive. In my convention, in this convention, R will always be taken as positive. Like for example, say you have more than one surface. So like this. I told you this is not convex. Let's see. Let me take R as 1 and R as 1. So this is 1, this is 2, and this is 3. These are the refractive indexes. Iski power nikalna. So when you have more than 2 surfaces and they're very close to each other, add powers. So you can find the power of this surface and add the power of this surface to this. Nikalna power. Concave side is 1 minus 2 is minus 1. 1 minus 3 is minus 2. So this becomes minus. So net power kitni aa gayi? Minus 3. So it's converging or diverging? So it is convex or concave? Finished. So it is not the shape, it is its power which will define whether it is a convex lens or a concave lens. Clear? So one thing is power. Now, coming back to where I started from. Once you understood how to calculate power, then I'll give you the formula for refraction. And the formula for refraction is extremely simple. It's mu1 by x plus mu2 by y is power. Mu1 by x plus mu2 by y is power. Like for example, say mu1 is 4, mu2 is 2, x is 1 meter, r is say 0.5 meters, and I want you to find the value of the image, the distance of the image. Karna, fill in the blanks. Okay, ji, can we do it? Let's fill in the blanks. What is mu1? What is x? What is mu2? What is y? I want to find out. What is power? कितना आ गया? What is y equal to? जो भी आ रहा है बता दो. y 0 आ रहा है ना? ठीक है. Now suppose I take this as 1 meter. अब y निकालना. R I have changed to 1 meter. Now what is the value of y now? So this will become 1. है ना? y कितना आ गया? Perfect. Now, what do you mean by a minus y? Y equals -1. It means the image is virtual. And if the image is virtual, that means the image is formed on the left-hand side. जिस मीडियम में ऑब्जेक्ट है, उसी मीडियम में इमेज है. If you get a negative y, that means the image is in the same medium in which the object was kept. Like in this case, the image is formed in a medium where the refractive index is difficult. Simple. Now suppose I were to take a case of a virtual object. I'll tell you how a virtual object would look like. I mean, this is real object because rays are diverging. It's real. Now suppose I have to show a virtual object. Virtual object. Then how do you recognize a virtual object? बताओ. this case, the incident rays are coming from which medium? And where is the object kept? In this case, इंसिडेंट रे किस मीडियम से आ रही है और ऑब्जेक्ट कहां रखा है? कॉन्केव कॉन्वेक्स नहीं, मीडियम से रिकॉग्नाइज करो. Recognize it from the medium. In this case, what is the medium of the incident rays? mu1. And where is the object kept? mu1. In this case, what is the medium of the incident rays? And where is the object kept? So that means it is virtual. So if the medium of the incident rays and the medium of the source is same, object is real. Clear? Absolutely clear ना? Note it down. कैसे बोलोगे? बोल के दिखाओ. Is same. Then the object is real, and if either of them are different, then. And how do you define for an image? How do you know whether? Yes, if the medium of the object and the image is same, then the real or virtual? Virtual. And if they're different, then it is. How do you mathematically come to know whether the image is real or virtual? The positive sign gives you a real image. The positive sign of y will give us will tell us that this image is a real image. And if y is negative, then the image is virtual. Okay. Like for example, say I take this lens. How this would be for your board exams, this is going to be the most difficult question. And even for J entrance, this will be a very good question. Suppose I take a refractive index here as mu1, this refractive index is mu2, and this is mu3. This radius of curvature is R1 and this is R2. And I've kept an object here at a distance x. And I ask you to find out the distance of the image. Find y. Can you find out? Try go. Done? And you would say it is plus फाइनली यहां से आएगा ना, इक्वल्स कॉनकेव माइनस, वेरी गुड, ओ फैंटास्टिक, मजा आ गया. ये fill in the blanks हो गया. There is no lens maker formula used. There is no sign convention I'm using. R will always remain positive. Power is always mu concave minus mu convex. X, if it is real, वो कहते हैं if an object is kept, take X as positive. And if Y comes out to be negative, it is virtual. If Y comes out to be positive, it is real. पक्का? Now to start with, let us first take refraction plus from plane surfaces. Say this is the plane refracting surface. This is mu1, this is mu2, and I've kept an object here at a distance x. See? What will be the refractive what will be the radius of curvature for a plane surface? Yeah. And my direct formula was mu1 by x plus y was mu1 minus mu2 upon r. R कितना है? Infinity. तो कितना हो गया? So power of a plane refracting surface is 0. एक तो ये note कर लीजिए that for a plane refracting surface power is 0, and this will be your formula for a plane refracting surface. So which means if I know x, I know mu1, mu2, I can find the value of y कितना होगा? So y is the negative sign shows इधर इमेज बन रहा है. mu2 mu1 का क्या होगा significance? If mu2 is larger than mu1, that means y will be greater than x. If mu2 is greater than mu1, that means y is, तो मतलब यहां पर कहीं इमेज बनेगी कब? When mu2 is, that means this is denser and this is rarer. Check करते हैं. If this is denser, logical. So I mean, you don't have to draw a ray diagram, you can directly use this formula. And if mu2 is less than mu1, तो मतलब y should be less than x. So obviously if it is rarer, so directly by using this formula you can avoid drawing a ray diagram. This will directly tell you negative sign for sure. That means the image is never going to be on the right hand side. The image is always going to be on the left hand side. And depending on mu1 and mu2, we will come to know whether our image distance is more or less than the object distance. That's the working formula. Clear? Now, this negative sign has to do nothing. It is just telling you that the image is on this same side. Now, for example, if I were to ask you that my object was here and the image is formed here, I want to know how much shift has happened. How much shift has taken place from x to y? What do you mean? Shift कैसे निकालोगे? X minus y will be x कितना है? तो x तो x ही है. और y कितना है? Don't use the negative sign here. So it will be minus into, so this is 1 minus note it down please. Shift का फॉर्मूला देख लो आप. It is 1 minus. याद कैसे करोगे? How will you remember it? By the किसी पता नहीं. Shift will be obviously object distance into 1 minus बाद में by पहले, बाद वाला refractive index by पहले वाला index. The final refractive index by an initial refractive index. So it is the distance of the object, which is x, into 1 minus mu 2 by. Clear hai? Acha. Now this shift will be either positive or negative, or zero. The shift will be either positive or it will be. When will the shift be positive? Thank you very much. When mu2 is greater than mu1, then shift will be negative. When mu2 is, लिखो. ठीक है ना? If mu2 is greater, that means if the medium on the right hand side is denser, the shift will be negative. लिखो. And when will the shift be positive? mu2 is less than. अच्छा, अगर ये mu2 less than होगा, मतलब ये rarer होगा, so the image will be towards the surface or away from the surface. But there are two situations. Either the image is on the right of the object, or the image is on the left of the object. कैसे पता चलेगा? How will you come to know? Absolutely. I mean, if shift is positive, it means the image is moving towards the refracting surface. And if F is, shift is, this is, or simply I can say if shift is positive, then the image is moving towards right, and if shift is negative, then the image is moving towards, because anyway you are keeping your surface on the right. Simple kar liya. Simple. So you have to remember this formula. Shift is 1 minus okay. This was refraction through one plane surface. Suppose I say we have to discuss refraction from a glass slab. The thickness of the slab is T. I've kept the object here. Say this is air, this is mu, and this is air. And the object is kept at a distance D. इसको एक काम करते हैं, इसको mu2 ले लेते हैं. Let's take this as mu1 and this also as mu1. How will you approach this problem? What will be your first step? Find the image position. Or you can find the final shift, net shift. So that means it will be a refraction from the first surface. Suppose ये first surface है, refraction हुआ. There will be a shift. From that shift, we will find the new position of the object. आप ऐसे करोगे ना? Assume करते हैं कि the first refraction happens here. This is the object. Maybe the image forms here. Then we know this distance. Say this is shift S. This will be. Now this will act as an object for the second surface. I need this distance. This will be. Then there will be a refraction here. And then there will be a shift here. आ रहा पास में हो सकता है इसका इमेज कहीं यहाँ जाके बने. Have you understood what I'm trying to say? What I'm trying to say is, for the first surface, suppose मैंने shift find कर ली. क्या होगी मेरी shift? By the way, S कितना होगा? अभी निकाला था ना हमने. D into 1 minus पक्का. This shift I found out. Now for the second surface, this is the second surface. This is the object now. This distance is how much? For this surface, I'll have to again find shift. Now my distance is going to be है ना भाई, ये S1 होगी और ये then I'll add them depending on whether the shift is in the same direction or in the opposite. पहले तो आप इसको नोट कर लो, फिर मैं आपको इसका I'll tell you a direct formula which you can directly use to find the result. Clear? Now, this is one way to do it, but let me make your life simple, because that is what we are for, to make your life simple. Shift. When it was a single surface, it was object distance into 1 minus final by initial. In case of a slab, the distance is irrelevant. It becomes thickness of the slab into 1 minus pehle by baad mein. ले, मैं क्या बोलता? ये mu1 होता, ये mu2 होता, single surface होता. I knew the distance of the object was x. The shift in this case was x into 1 minus. In case of a slab, the distance where it is kept becomes immaterial. मुझे इसकी जरूरत नहीं है. I need the thickness, which is, so this is mu1, this is mu2, this is mu1. अब the shift is the thickness into 1 minus इसका reverse. आप इसको याद कर लीजिए. So this will save all this effort. You could directly use this. अभी करता हूं, अभी लेते, चिंता नहीं ना कीजिए, सब हो जाएगा. पहले आप इसको याद कर. So this is a case when a slab was kept in the medium on which on the left and the right hand side the medium was same. लेकिन ये लड़की जो है, the girl from Meerut, बड़ौत बागपत, मानेगी नहीं. She says I travel 3 hours every Saturday and Sunday because I want to become an IITian. So you have no help in Bagpat. There's no proper center to teach. So what do students do from Bagpat? They come to Delhi to study. Any nearby center. But that takes a lot of, it's very expensive. But in a class, then you will not have all the students who are at the same level. I think the best thing which Udaan has done is, the positive about it is, I've been in this education field for almost so many years, and I realized that how can you ensure that the quality of the students is same? But in general coaching institutes, you have a batch of 30 students. There are only 2 or 3 students who are at that level. The rest of them average or middle level, or students who don't wish to study. But what I see in all of you is you have the desire to study. कुछ भी बताता हूँ, आप एकदम कर लेते हो. Miracle. Anything is told to you, you are able to absorb. What an absorption power. अब मिस मेरठ, बागपत आइए. आपने अभी एक इच्छा व्यक्त की थी कि सर हम मानेंगे नहीं, हम तो तीनों मीडियम ही अलग लेंगे. ठीक है, क्या करें, मजबूरी है. Let me place an object here. Say at a distance x. This thickness is t. And you want to find the net shift. Till now, we have reached a situation where if we have a glass slab and the refractive index says mu2, and if it is mu1 on both the sides, then I have no issues. This is 1 minus 1 minus 1 by. Life is chilled out at this point of time. That's the problem. So let me make your life simpler. एक काम करते हैं. मैं इसको एक ग्लास स्लैब बना देता हूं. ठीक है. Good question. I can't change this because mu1 is mu1 and the object was kept here, no? So that means the incident ray has to come from mu1. इसको तो मैं कुछ नहीं छेड़ सकता. स्लैब बना दिया मैंने, but I can't touch this, I can't change this medium. But I can take this as mu3. पूछो क्यों? रे तो उधर जा ही नहीं रही. ऑब्जर्वर तो यहां बैठा है. तो यहां जब रे जाएगी नहीं तो म्यू 500 ले लो. 3 ही क्यों? You can take any medium you want, but then only why mu3? Because I want to use the superposition principle. कैसे? Slab 1. अंदर क्या है इसके माल? लेफ्ट में क्या लिया, राइट में क्या है? Superposition means this slab has an independent shift and this slab has an independent shift, and I'm adding both these shifts. So when I'm talking about this slab, this is mu3, this is mu1, and outside is mu3. And when I'm taking this slab, then this slab is not existing. So I have on the left hand side mu3, this is, and on the right hand side is what will be the shift of this? Thickness कितना है इसका? X. X into? Wow. इसका T. तो मजा नहीं आ गया जिंदगी का? Over and out. And final shift will be कैच कर P. ठीक, बेटर. You know what this result means to us is imagine you have a situation like this. Slab 1, slab 2, slab 3. This is mu1, this is mu2, this is mu3, this is mu4. Here there is an object which is kept in mu0 और इधर आप बैठे हो. How simple. You're sitting at a distance x. This is thickness T1, this is thickness T2, this is thickness T3. And he says, भाई साहब मैं यहाँ बैठा हूँ, ये मुझे ऑब्जेक्ट कहाँ दिखाई देगा? Where can I see the object? So you are required to find out shift. आइए मचाते हैं. सीधे सीधे फॉर्मूला लिखते हैं. Shift equals, and now you are measuring shift from this point. O से कितना shift हुआ, right or left? If this shift is positive, it is towards right. If it is negative, it is towards left. आइए मचाते हैं. सबसे पहले क्या करेंगे आप इसको? और यहाँ क्या लोगे? क्या लिखूं? X into upon. I like it. मजा आ गया? चलो स्यापा खत्म. Interesting. Now suppose I go to the next level, which is I silver or silvering of a glass slab. Wow. Right? There's a slab. This refractive index is, say, this is air to start with. This refractive index is mu. ये अपने इसको silver कर दिया. This thickness is dt, and I've kept an object O at a distance. And I wish to find its image. There'll be a refraction here. There'll be a shift here. ऐसे करते हैं. पहले एक refraction करा. क्या होगा? There'll be a shift here. Then reflection, and then एक और refraction. इसको थोड़ा simplify करते हैं. I convert this system into something like this. A slab plus a mirror followed by another slab. Matlab. In this case, it is a refraction here and reflection here. The ray does not come out. But what I'm saying is, let the ray come out. Aane do usko bahar. Then it will strike the mirror. Up, since you brought the ray outside, which it cannot or should not, so I have to bring the ray inside also. So that means air, mu, air. The ray comes out, gets reflected, and then, are you clear on this? Like, which means this is T, this is T, right? And this distance was? What will be the shift here? That means अभी ये ऐसे है. And the image is now here, and this is the clear. So what is the distance of this? Now this becomes the first image. Now ये पूरे slab से इधर तक shift हुआ, मैंने shift निकाल लिया. Now I convert this into a plane mirror. What will be this distance? बोलो. X. Fantastic. ठीक है. इसका इमेज कहां बनेगा? इधर. तो कैसे? Let's try it on this first. Object. Denser. Rarer. ऐसे आया ना? What is this? And what is this distance equal to? बोलो. अब इसको यहाँ क्या मिला? मिरर मिला. तो ये रिफ्लेक्ट होकर कैसे जाएगी? कैसे बैक? ऐसे. तो इसका कहाँ इमेज बनेगा? तो this image will be somewhere here, and what will be this distance equal to? X, right? Now then again the shift has to be towards left. ये reflect हो गया, but इस image को इसको वापस भी लाना है through this glass slab. तो shift will be again towards left. वो shift कितनी होगी? Again S. तो ये डिस्टेंस कितना हुआ फाइनली? लिख लो उसको. This is the final position of the image from the plane mirror. Do you agree? आया आपको समझ में कि नहीं आया? लिख लो उसको. मैं इसको थोड़ा सिंप्लीफाई कर दूं आपके लिए. Let me simplify life for you. देख, ये क्या था? ये क्या था? Silver, right? This distance was fantastic. First of all, slab shift from the slab. कितना shift हुआ? ये distance कितना होगा? ये फाइनली इमेज यहां बना, तो ये भी डिस्टेंस सेम होगा. कितना? फिर ये वापस अंदर की तरफ शिफ्ट होगा. कितना शिफ्ट होगा? अब ये डिस्टेंस कितना हो गया? फैंटास्टिक. तो ये डिस्टेंस मैंने कहां से मेजर किया? परफेक्ट. We'll take it further in the next class. Convinced? We'll do some questions on this and then we'll take it.
So let's start with the oxygen family. Oxygen family consists of oxygen, sulfur, selenium, tellurium, and these are the four elements. One more last element is the radioactive element. So we deal with the chemical properties and physical property of mainly these four elements. Okay. Oxygen, sulfur, selenium, and tellurium. So the valence configuration of oxygen is NS2, NP4, NP4, and these are 16th group. Okay. So they are similar with the nitrogen family in terms of little bit of electronegativity and reactivity. Oxygen, the valence configuration is NS2, NP4. So S orbital consists of 2 electrons. P orbital consists of 4 electrons. To gain octet, it wants to accept 2 electron. It wants to accept 2 electron gain करने के बाद P6. Okay. So तो इनकी tendency ये है कि it wants to gain 2 electron or it wants to lose all 6 electron. So it is difficult to lose all 6 electron, but it is practically it lost 4 electron, right? Oxygen, the oxidation state is maximum up to +2 and to -2. 4 electron can never be, lost by oxygen because it is most electronegative element in their respective groups. Now, starting with the physical form or physical properties of oxygen family. Pehli slide. First slide. First slide. So these are known as chalcogens. Oxygen, sulfur, selenium, tellurium, and polonium. Polonium are chalcogen. Clear? ज्यादातर ये ऑक्साइड्स के फॉर्म में एग्जिस्ट करेंगे, फ्री फॉर्म में बहुत कम मिलेंगे एक्सेप्ट ऑक्सीजन. So all are mainly non-metal. All are mainly non-metal. And the electronic configuration, as it is mentioned, that NS2NP6. So commonly these are known as chalcogen. Most reactive element is oxygen. Irrespective the bond of oxygen is very strong exothermic. Oxygen double bond को break करना बहुत मुश्किल है. Still ये बहुत reactive है. Reason that the size of atom is very small. So easily they can able to form covalent bond. Clear? लगभग सारे metal, non-metal, almost all element of periodic table react with oxygen to form different type of oxide. Clear? Next slide. So let's start with the general physical properties. First is the atomic and ionic radii. See, atomic and ionic radii, mainly atomic radii. Ionic radii, it is difficult to convert these ions in the negative form. Okay, so the atomic radii continuously increases as we move down the group. So oxygen is the smallest element. As we move down the group, the atomic radii increases. A certain change in between sulfur, selenium is also observed due to the presence of d10 electron. D orbital में 10 electrons है, उनकी वजह से certain change आपको दिखेगा. Poor shielding effect की वजह से selenium to tellurium जब जाएंगे, the atomic radii is approximately similar due to poor shielding effect of d10. तो जिस atom के अंदर d10 electron आएंगे, उसमें shielding effect देखने को मिलेंगे. So as we move down the group, the atomic radii increases as well as the ionic radii increases. अच्छा, दूसरा कि अगर if oxygen accept 2 electron is converted to O2 minus, sulfur accept 2 electron it is converted to S2 minus. So these ionic radii also increases down the group. So atomic and ionic radii increases down the group. The only exceptional case is due to poor shielding effect of D10 electron. बाकी सब चीजें similar है. Catenation property. Why we are reading catenation property? All p block element exhibit catenation power, right? So if an atom X forms in bond with X, and this is X, and it undergo polymerization process. So this process is known as catenation power. In p block element, highest catenation property is shown by carbon. How to define catenation properties? If carbon form bond with oxygen, carbon form bond with nitrogen, carbon form bond is carbon. The bond energy of carbon-carbon is equivalent to these bond energies. So its tendency to form bond with carbon is highest. So all catenation property is shown by p block element, especially oxygen, sulfur. Oxygen, the catenation property is very few. Maximum we can able to see the peroxides bonds, right? But in sulfur, the catenation property is very frequent. It form mainly S8 form, and some polymeric exist. Polymeric form of sulfur is also exist. Clear? So the catenation property decreases down the group. Oxygen shows limited catenation power due to the formation of additional pi bond. So they say maximum catenation O2 2 minus. This is a peroxide bond. Except O2 2 minus, very few ozone 1/3 oxygen attached, but rest all form lesser. As we move down the group, the catenation property decreases. Next is density. Density is common as of nitrogen family. If you go down the group, the density increases. Why density increases? Increase in atomic mass. But atomic volume also parallelly increases, but atomic mass predominant, right? So as we move down the group, the density increases. Melting point and boiling point. This also shows same result as of that nitrogen. Both melting and boiling point depend upon the intermolecular force of attraction between the two atoms. Oxygen, the melting and boiling point is very low because it form in a dimer form. O2 के फॉर्म में गैस के फॉर्म में एग्जिस्ट करेगा, तो उसकी मेल्टिंग और बॉइलिंग पॉइंट बहुत कम होगी. लेकिन जैसे जैसे हम नीचे आएंगे, मेटल के बीच में मेटालिक बॉन्ड बनेंगे जो बहुत स्ट्रॉन्ग बॉन्ड है. So both melting and boiling point increases as we move down the group, and it is shown in almost all p block element. सारे p block element में down the group melting और boiling point बढ़ती है. Next is that electron affinity. There is an exceptional case of electron affinity. See this train. Highest is sulfur, then Se, then Te, then Po, and sulfur and oxygen, sulfur is higher. Clear? So how do you define electron affinity? Any atom X, if accept one electron, it is converted to X minus. It is converted to X minus. Now, see, if the atom X consists of nucleus and electrons, right? To remove an electron from the valence cell, the amount of energy required to remove an electron from the valence cell is known as ionization energy. So what we say, if this is a proton, this is electron, तो ये इलेक्ट्रॉन जितने नजदीक आता है प्रोटॉन से, इसकी एनर्जी कम होती है, ये एनर्जी एमिट करता है. So if I remove this electron, I have to supply some amount of energy which is known as ionization energy. If a neutral atom, one electron comes, the energy release is known as electron gain enthalpy or electron affinity. So if this X accepts one electron, it is converted to X minus. If this X accepts one electron, it is converted to X minus. Now, when one electron enter a neutral atom and it is converted to negative charge, the energy release is known as electron gain enthalpy. So this electron gain enthalpy value is depend upon this X. This electron gain enthalpy value depend upon this X. So the factor which affect electron gain enthalpy is one, A is size, B is electronic configuration, size and electronic configuration. Smaller the size of atom, smaller the size of atom, higher will be the tendency to accept the valence electron and higher will be the electron gain enthalpy. Second is the electronic configuration. If let's say this atom accept one electron and achieve octet, so the electron gain enthalpy will be higher. So we are seeing the size as well as electron configuration. Smaller the size, higher will be the electron gain enthalpy. Stable the electronic configuration after accepting one electron, higher will be the electron gain enthalpy. So these are the two factors. Now, if with respect to electronic configuration, all the element of oxygen family, the electronic configuration is identical. In terms of size, if I say oxygen and sulfur, the size of oxygen is smaller as compared to sulfur, but still the electron gain enthalpy of sulfur is higher than the oxygen. Clear? Why it is? Because the size of oxygen is very small and it is highly electronegative element. तो बहुत ज्यादा electronegative element है, size बहुत छोटा है. So it consists of large number of electron. Valence cell 6 electron in a very small area. So can I say oxygen is electron dense? Oxygen is electron dense. The negative charge in oxygen in a small area is very high. So the incoming electron faces an inter-electronic repulsion with the incoming electron. So if these electrons face repulsion with this electron, it wants to remove this electron. So this electron, when come to this, the electron gain enthalpy decreases. In case of sulfur, the size is relatively bigger as compared to oxygen, and the electronic configuration is identical. तो जब वो इलेक्ट्रॉन आएगा तो उतना रिपल्सिव फोर्स नहीं होगा, इसलिए सल्फर की इलेक्ट्रॉन गेन एंथैल्पी ऑक्सीजन से ज्यादा है. तो जितनी ज्यादा इलेक्ट्रॉन गेन एंथैल्पी होगी, higher the electron gain enthalpy, higher will be the energy release, and higher will be the tendency to form ionic bond. Higher will be the tendency to form ionic bond. Is it clear? So the electron gain enthalpy, oxygen, the second electron gain enthalpy we are talking. Suppose a neutral atom accept one electron, it is converted to X minus, the energy release is called first electron gain enthalpy. Okay. Now, if say this X minus accept one more electron, X minus accept one more electron is converted to X2 minus. Clear? So when second electron enter to the X minus, we have to add energy, and the second electron gain enthalpy is always positive for all atom, irrespective of their electronic or stable configuration. See, if oxygen, the valence configuration of oxygen or all the element of oxygen family is NS2 and NP4. If it accept one electron, the configuration now become NS2, NP5. If it gain one more electron, the NP5 is converted to, and it gain stable configuration. Still, the second electron gain enthalpy is positive. Why? Because this atom is neutral. This atom is neutral. So it is easy to accept one electron. When this is negatively charged and you add one more electron, there is a repulsion between this negative charge and one electron. So it is difficult to introduce second electron in a negative species. Clear? So the second electron gain enthalpy is positive for almost all atoms of oxygen family. See the difference between when oxygen accept one electron, it is converted to O minus and the energy release is minus 142. Whereas the sulfur, the electron gain enthalpy is minus 200. So for sulfur, the electron gain enthalpy is approximately 60 kilojoule per mole higher as compared to oxygen. तो बहुत छोटा difference नहीं है. So the difference is oxygen, sulfur, selenium, tellurium, then polonium. Okay, and this is also for halogen also. Between fluorine and chlorine, the size of fluorine is smaller. So the fluorine must have larger electron gain enthalpy as compared to chlorine. But in actual practice, chlorine has stronger electron gain enthalpy as compared to fluorine. And the third is ionization energy. See, ionization energy is also depend upon different type of factor. Out of that, first is size of atom. Smaller the size, higher will be the ionization energy. Second is octet. Stable molecule, it is difficult to remove electron. So all element, if you go down the group, the size of atom increases. We are not talking about the electronic configuration because all element has similar electronic configuration. So the ionization energy increases as we move down the group. Some exceptional behavior are also observed due to poor shielding effect. Clear? Decrease तो बोला नहीं, decrease, increase बोला मैंने. So ionization energy decreases as we move down the group. The highest ionization energy किसकी है? Oxygen. But the second ionization energy is always greater than first. Suppose एक oxygen atom है, if it converted to O plus an electron, the energy required is E1, and if this O plus one more electron is eliminated, the ionization energy is E2. The E2 is always higher than E1. Clear? This is also valid for all element of P block. Second ionization energy, irrespective of their stable configuration, it is always higher as compared to the first. So it is always difficult to remove second electron. And third ionization energy is much more higher than second. So if you increase one more electron, the requirement of energy is higher. And as you move down the group, the size of atom increases, due to which ionization energy decreases. So least ionization energy is for polonium and highest will be oxygen. Third is, next. The element which are present are oxygen, polonium. So oxygen exists in which form? Diatomic. sulfur S8, selenium Te, and polonium PO. See, oxygen exists in O2 form. O double bond O. So this is one sigma bond and one pi bond. Generally, pi bond is the sidewise overlapping of p orbital or orbitals, right? If you increase the size of these atoms, this bond length, the sigma bond length is increases. Sigma bond length अगर increase हुआ तो sidewise overlapping हो पाएगा? नहीं हो पाएगा. That means to form a pi bond, the size of atom must be smaller. So the oxygen is only element which can able to form pi bond. Sulfur cannot form pi bond with another sulfur because the bond length is increasing. And second thing is that OO bond energy is very high. And if you see sulfur, that is not very large. So it is unable to form pi bond. So oxygen, due to the formation of pi bond, it gained the stable configuration in O2. So oxygen exists in a gaseous form. Oxygen exists in gaseous. Now sulfur form S8. Sulfur S8. Se S8. Te T8. PO PO. Tendency to form these polymer decreases as we move down the group. So S8 is the highest tendency to form sulfur is S8. Selenium very low. Selenium again low. So as you move down the group, the formation of S8 will be slower due to heaviness of these atoms. Clear? Now, sulfur S8 exists in this form. Clear? So this reject form, the lone pair, sulfur consists of NS2 NP4, no? So if it forms two bonds, there are two lone pairs. One lone pair in the s orbital and second lone pair in the p orbital. So the lone pair are in the opposite directions, right? Or our tetrahedral form, lone pair are in opposite direction and it form S8. So as you move down the group, the atom size is increasing. So this bond length increases, stability decreases. So the most stable is S8, least stable is PO8. To prepare PO8 is very difficult. Now, this is also in the normal temperature. If you increase the temperature, these bonds form and it come into zigzag conformational isomers kind of thing, right? This bond form break, so the ring will be open and it form huge number of bond and form a polymeric form of sulfur. Clear? Clear? So what we have written that as the stronger S8 is a bigger molecule, octaatomic. So it form in the van der Waals force between the polymolecule, right? So they exist in a solid form. So oxygen exist in gas, sulfur exist in waxy solid, and rest all element in the solid form. So it is easy to vaporize sulfur because the van der Waals force between S8 and second S8 is very weak. Clear? Clear? The properties of oxygen, general chemical property. As we have already discussed, the most reactive element is oxygen. So why oxygen is most reactive? Because it is small in size. So why small in size is more reactive? Because the bond formed with other element, the bond energy is higher and it is exothermic. That means if oxygen form bond with another element, the bond energy release is very high. So delta H will be negative. If delta H negative, the free energy delta G will be negative. So it is a spontaneous process. So it is more reactive. Second thing is it is highly electronegative. If it is highly electronegative, the tendency to accept electron is very high. So it is very reactive. Third is to form p-pi bond. So only oxygen can form p-pi bond. So multiple bond can form with oxygen. Carbon form double bond with oxygen. Nitrogen form double bond with oxygen. Carbon can form triple bond in carbon monoxide with the resonance, right? Sulfur can form double bond. Phosphorus can form double bond. So p-pi bond is the third reason. Third is the instability to explain. Oxygen is the only element we can able to form two bonds. Clear? So oxygen के ये तीन property वजह से oxygen सबसे ज़्यादा reactive होगा. Now the first reactions of oxygen family is the formation of hydride. See, if oxygen is treated with hydrogen, it forms hydride of H2O. But sulfur cannot be reacted in this manner to form hydride. To prepare hydride of sulfur, we required some salt, Na2S, which is treated with H2SO4 to give H2S. Clear? Na2S, the oxidation state of sulfur is 2-. Sodium is metal. So it consists of 2- charge. This 2- attack this H plus and form H2S, and this SO4 and sodium can form Na2SO4, right? So H2S can be prepared by this method. Now, selenium can be also formed by some element of magnesium selenium. It is treated with HCl to give H2S and MgCl2. Tellurium also form metal with potassium, which is treated with HBr to form H2Te plus KBr. Clear? So these hydrides are water, H2S, H2SE, H2Te. Clear? All are acidic in nature, in which water is neutral. Water is neutral. Why water is what neutral? Because when H2O form an equilibrium with H plus and OH, H plus is 10 to the power minus 7, 10 to the power minus 7, and it is 10 to the power minus 14. Kw is 10 to the power minus 14. So it is neutral. How you define neutral? When the concentration of H plus, I'm coming to the oxidation state in the third point. Water give H plus and OH minus. So remember that the neutral point, acidic point and basic point is not related with the pH. ये pH से related नहीं है. अगर concentration of H plus and concentration of OH are equal, then it is neutral. If the concentration of H plus is higher, OH is higher, basic. So acidic, basic and neutral are depend upon the H plus and OH concentration, right? So if I say this H2O give H plus and OH, this is the dissociation of H2O. Clear? So this is dissociation of H2O. Pure water can never be acidic. Pure water can never be acidic or basic. It is always be neutral. But in these cases, it can be acidic at elevated temperature, at normal temperature. The reason behind that, see in this reaction, if this reaction goes to the forward direction, H and OH bond break. In the backward direction, H and OH bond form. So can we say forward reaction is endothermic? Forward is endothermic and backward is exo. So if the reaction goes forward direction, energy is absorbed. If the reaction goes backward direction, energy is released. Now see the effect of temperature. If I increase the temperature, can we say that if we increase the temperature, that means we are adding energy. If we are adding energy, that means it proceeds to the endothermic path. So it goes forward direction. If it goes forward direction, the concentration of H and concentration of OH increases. So let's say I have raised the temperature to 60 degree and the concentration of H plus, let's say 10 to the power minus 6, 10 to the power minus 6. Now the Kw become 10 to the power minus 12, isn't it? And the pH at this moment is 6. pH at this moment is 6, but the solution is neutral. If I increase the temperature and it decrease to 10 to the power minus, increase to 10 to the power minus 5, 10 to the power minus 5, then the pH will be 5 and the solution become neutral. That means if I increase the temperature of water, the pH decreases, but the solution is neutral. If I take ice, temperature at minus 2 degrees centigrade, the Kw decrease from 10 to the power minus 14 to 10 to the power minus 18. At that moment, the concentration of H plus is 10 to the power minus 9, OH is 10 to the power minus 9, pH is 9, but the solution is neutral because both the concentration are same. But in case of H2S, if I add H2S in water, it will give H plus and HS minus, right? So it can increase only one ion, that is H plus. Okay, so H2S is always acidic. H2S is always acidic, and it undergo two type of dissociation. One is H plus plus HS minus. Second is HS minus dissociate to give H plus and S2 minus. Combinedly, we can say H2S can give 2H plus and S2 minus, which is K1 into K2, that is known as equilibrium constant of this H2S, right? So H2S become acidic. Now, as I move down the group, the conjugate base H2S form conjugate base of HS minus. H2S form conjugate base of HS minus, and water form conjugate base of HO minus. The conjugate base has tendency to accept this H plus. Now, how we define the strength of conjugate base? Any atom which consists of negative charge, we say it is conjugate base. If you increase the size of this negative charge, if you increase the size of this atom, the intensity of negative charge decreases and the strength of conjugate base decreases. And result will be the respective acid will be more acidic. See, H2O, the conjugate base is H2O, the conjugate base is OH minus. For H2S, the conjugate base is SH minus. For H2SE, the conjugate base is SEH. For H2T, the conjugate base is TH minus, right? So as I move down the group, the size of atom increases. That means this negative charge decreases. That means this is weak conjugate base, this is strong conjugate base. Weaker the conjugate base, higher will be the strength of acid. So among H2O to H2T, highest acidic nature is H2T. So can we say as we move down the group, the acidic strength increases? See the value I have not mentioned. The Kw for water is 10 to the power minus 14. Similarly, the KWH2T is approximately 10 to the minus 8, in the range of 10 to the minus 8. So H2T is acidic in nature. All these hydrides are colorless, odorless liquid. The thermal stability decreases as we move down the group. The most stable one is H2O, and least stable is H2T. Why most stable is H2O? Because H and O bond is stronger, whereas H and T, the bond length is very large and it is weaker. So thermal stability means at what temperature it undergo dissociation. So the most stable is H2O. Thermal stability always for almost all hydride decreases down the group. Clear? The third point is bond angle. See the hybridization of water. Hybridization of water is sp3, isn't it? So what will be the bond angle? 109. So that means if it is sp3, the hybridization is 109 angle. Hydrogen, hydrogen, lone pair, lone pair. We know that the repulsion between lone pair is maximum as compared to lone pair, bond pair, as compared to bond pair, right? So this lone pair repulsion is maximum. To compensate this repulsion, these bond angle will be decreases. So this bond angle decreases, right? Clear? Now, why this bond angle decreases? See, these electron repel these electron because they are negatively charged. See, if I increase the bond length, this atom, central atom and hydrogen, bond length increase. That means the electron density in this bond is decreases. If the electron density in this bond length is decreases, the repulsion decreases. Can I say increase the bond length decreases interbond electronic repulsion, due to which the bond angle decreases? so that these lone pair can get higher space. So in these hydrides, the bond angle decreases as we move down the group. Clear? Why the bond angle decreases down the group? Yeah. See, H2O, the bond angle is 104, H2S 92. The difference is very high. H2SE 90, H2T 90. Clear? Clear? So there are four things. One is thermal stability. Thermal stability decreases down the group. Second is acidic nature, increases down the group. Okay. Third is bond angle, decreases down the group. Okay. Fourth is pH, it decreases down the group. Water is neutral. Okay. Fifth is equilibrium constant for their H plus donation. It also increases down the group. More acidic, higher Ka. Clear? See the equilibrium constant, which we have already discussed, is mentioned. The equilibrium constant of H2O, 1.8 into 10 to the minus 16. Yeah, this is not equilibrium constant, this is K. There is a difference between equilibrium constant and K. In K, let's say you have taken 1 liter of water. 1 liter of water means 1 kg of water. 1 kg means 1000 gram. 1000 gram divided by 18 is 55.5 moles. So 55.5 mole undergo dissociation at 25 degrees centigrade to give alpha. So 55.5 minus alpha, that is 10 to the minus 7, 10 to the minus 7, 10 to the minus 7. You divide 10 to the minus 7 square multiplied. I'm saying that H2O dissociate to give H plus and OH. 1 liter means 55.5 moles. 55.5 minus alpha, alpha. We know that the value of alpha is 10 to the minus 7. So put 10 to the minus 7, 10 to the minus 7. Generally, we used to neglect this value, right? But in the KW, you write H plus into OH minus, unable to divide this water. In the Ka form, you divide 55.5. So the value is 1.8 into 10 to the minus 16. See, the value is 10 to the minus 7. 10 to the power minus 4. See, this is 10 to the minus 3. H2TE, the value is 2.3 into 10 to the minus 3. You know the value of Ka for HF. It is approximately 10 to the minus 2. So it is similar acidic as compared to HF. Clear? So the stability as well as the reactivity of hydrides. Now, third point is reducing character. Reducing is simple, that all hydrides except water are reducing agent. The reducing power increases down the group. Why reducing power increases down the group? Because the bond length increases, so it is easy to donate H minus, right? So reducing power increases down the group. So this is halides. See, all element of alkali metal, when treated with halogen, it give halide of MX2. Clear? Generally, these halides are of different type, from 2 plus 2 to plus 7, except oxygen. See, oxygen form only one halide with fluorine. Fluorine react with oxygen to give F2O. This is known as oxide. नहीं है, ऑक्साइड कब बोलते हैं? जब ऑक्सीजन, हाँ. अब क्लोरीन फॉर्म Cl2O3, ClO2, Cl2O7. These are the three oxides of oxygen with chlorine. With bromine, only Br2O. And with iodine, I2O5. Sulfur form large number of halides except iodine. आयोडीन के अलावा सल्फर बहुत सारे halides बनाएंगे. SF6, S2F10, SF4, S2F2. Similarly with chlorine, with bromine. Clear? इनकी hybridization क्या होगी SF6 की? The structure is, what is the hybridization of SF6? sp3? sp3 D. करो. How you calculate hybridization? इतना लंबा मेथड की जरूरत नहीं है. हाँ, the valence, see, count the valence electron. 6. Number of atom by 2. It is 6. Write SPD. This is 6, 1, 3, 2. sp3d2. So sp3d2, what is the shape of sp3d2? Octahedral, perfectly octahedral, no lone pair. Clear? What is the hybridization of SCl5? SCl4. SCl4. SCl5 is not formed. Again D2. ऐसे calculate करो. Sulfur, the valence is 6, number of atom attached 4 divided by 2, 5. sp3d1, triangular, planar, triangular, but there are only 4 halogens and 1 lone pair. So lone pair is present in axial or equatorial? Equatorial. अगर हम लोन पेयर को एक्सियल में रख देते हैं ना, तो इट रिपेल विद 3 बॉन्ड्स, 3 बॉन्ड के साथ रिपल्शन होगा. बट अगर हम इक्वेटोरियल में रखेंगे तो इट रिपेल विद 2 बॉन्ड्स. सो दीज आर क्लोरीन, क्लोरीन एंड क्लोरीन. ओके, so this is the structure of SCl4. So you can able to prepare all the structures of halides. Clear? So these are the halides. You have to remember the nature of halide as well as the type of halide form. We have completed this. Next. Now this is oxides, and oxides are very important. See, sulfur, I'm not writing oxygen because we are dealing with the oxide. So these elements react with oxides, O2, to form different type of oxide. See, sulfur, start with the sulfur. When you react sulfur with oxygen, it gives SO2. Mainly, these form 2 type of halide. Okay, 2 type of oxides. One is MO2, second is MO3. Other oxides are also possible, but in general, if you see, these halogens or these metal react with oxygen to form MO2 and MO3. These 2 type of oxides. Now, MO2 and MO3. MO2, in case of MO2, sulfur form SO2. What is the hybridization of SO2 and what is the shape of SO2? SP, दोबारा करो. SP2. How many pi bonds? हाइब्रिडाइजेशन में बड़ा कंफ्यूजन है. देखो, सल्फर सेंट्रल एटम है, 6/2, 3 sp2. sp2, what is the shape of sp2? Triangular planar. So one lone pair, this is oxygen, this is oxygen, this is sulfur, forming 2 pi bonds. Okay, so the shape is angular. So shape is angular. So this is the structure of SO2. SO2 is gas, so no polymer form. SO2 exists in this form. But if you see the structure of SeO2, it is also sp2, triangular planar, having 2 pi bonds, but it undergo polymerization and form a solid form. Clear? The polymerization of SeO2 is like this. See this structure. This is a cyclic chain of double bond, single bond, double bond, single bond. So, and similarly T and PO. So we can say the MO2 kind of structure, the sulfur form gas, SO2, single district unit, whereas SeO2, TeO2 and POO2 exist in a polymeric form of chain like this. Clear? Clear? So I'm talking about how these oxides are formed. How these oxides are formed. This is the type of oxide which I have mentioned. Okay, first we will learn the different type of structure of oxides, then we'll go ahead with the normal peroxides and all that. Clear? Clear? So this is all about the structure of MO2, not oxides. MO2. In MO3, sulfur react with oxygen to form SO3. What is the hybridization of SO3 sulfur? sp2. sp2. How many double bonds? Two नहीं है तो 3 तो हो गई. See, first write down the valence configuration. This is 3s2, 3p4. So s orbital consists of 2 electron, p orbital consists of 4 electron. 1, 2, 3, 4. Clear? Make one vacant d orbital. Make one vacant d orbital. Clear? Third step, calculate the oxidation state of this sulfur. Here the sulfur, the oxidation state is +6. +6. So we required 6 unpaired electron. This method is very good, and this method is also used to calculate the hybridization of coordination compounds. Clear? So this is +6. So we required how many unpaired electron? 6. How many unpaired electrons are present right now? 2. So we have to excite the electrons such that number of unpaired equals to oxidation state of the central atom. So if I excite this electron, now there are unpaired electron are 4. 1, 2, 3, 4. If I excite this electron also, the unpaired electron are 6. And we required 6 unpaired electrons. There are 6 electrons, right? Now, this central atom is attached with how many atoms? 3 atoms. So we required 3 unpaired electrons. 3 unpaired electrons. So count this 1, 2, 3. So these are 3 unpaired electrons. Yes. So this is sp2. Now how many unpaired left? Number of unpaired left equal to number of double bond. So this is, if this is sp2, the shape of sp2 is triangular planar. The shape of sp2 is triangular planar. Number of unpaired left are 3. Therefore, it forms 3 double bonds. Okay? Clear? Clear? Find the hybridization number of double bond in SO4 2-. Number of double bonds are sp3 is correct. Number of double bond? See, this is SO4 2 minus First, you have to calculate the oxidation state of this sulfur, which is +6. Write down the valence configuration: 3s2, 3p, 4. S consists of 2, P consists of 4. And there is a vacant d orbital. Vacant d orbital. So if it is 6, you have to make 6 unpaired. Number of atom attached with the central atom is, so you calculate 4 unpaired electron. Sp, how many double unpaired left? That means number of double bond is 2. So make tetrahedral structure having 2 double bonds and 2 single bond. Both single bond consist of negative charge. So the hybridization is sp3, shape is tetrahedral, number of double bonds are 2. Clear? So we are talking about the oxides. Sulfur form mainly two type of or three type of oxide. One is SO2, other is SO3. So SO3, the structure is triangular plane. So write down SO3 exists in different polymeric structures. One is single unit of SO3, which consists of 3 pi bonds, and second is cyclic structure. The cyclic structure may be of two types. One, it consists of 3 unit of SO3. 3 unit of SO3 combined with each other. Clear? 3 unit of SO3 combined with each other. Now, the combination reaction is simple addition, which you have already read in the organic chemistry. See, this is SO3, oxygen, double bond, sulfur. These are the 2 units. See, between sulfur and oxygen, oxygen is more electronegative, and this is a pi bond, which is weaker bond. So both the electrons are taken by this oxygen. Now this oxygen consists of negative charge, this sulfur positive. These 2 electrons are taken by this oxygen. This negative approaches this sulfur, and this approaches to another sulfur, right? So this way they can be able to form a cyclic compound, which consists of, each sulfur consists of 2 double bond O. And the oxidation state remain constant. This is not a redox reaction. If you can able to calculate the oxidation state, sulfur plus 2, 4, 5 and 6. All sulfur in the 6. This is simple addition. Addition of 3 monomeric unit of SO3. Clear? Clear? Now the second is tetramolecular model of SO3. In the tetramolecular, 4 molecules of SO3 combined with each other. So it consists of 4 SO3 molecule. 1, 2, 3, 4. This consists of 3 monomeric unit. It consists of 4 monomeric unit. Clear? So SO3 can exist in 2 form. One is tri-molecular, other is tetra. Clear? SO3 can also form n number of monomeric unit with the chain structures, but they are highly unstable. But SeO3, you see the structure of SeO3, it can form n number of monomeric units, like SO3 can also form, but the addition, the structure of SeO3 can exist like this. So they are the polymeric unit of SeO3 and they are solid in nature. Solid in nature. So this is the structure of SeO3. This is also the simple addition reaction of SeO3. Simple addition reaction of SeO3. Upon hydrolysis, SO3 when treated with H2O in presence of H plus, it will give H2SO4. It will give H2SO4. Similarly, if H2O is treated with acidic water, it will give H2SO3. Clear? Sulfurous and sulfuric acids. Now, H2SO4 is highly hygroscopic in nature. So it can absorb water to dilute. So SO3 is added in H2SO4 to stop the process of this. Suppose, let's say, we have taken H2SO4, the use of SO3. SO3 is used to protect this H2SO4. There are two types of solution. One is primary standard, other is secondary standard. The solution absorb water from atmosphere and get diluted. For example, if you prepare H2SO4 100%, 100% pure H2SO4, clear? It absorb H2O from atmosphere. It absorb H2O from atmosphere, and the 100% is become 99, then 98. Slightly it is decreasing. Let's say in the lab you required 100% pure H2SO4. They prepare it 100% pure H2SO4, packed it and sent to the lab. On the way it absorb water. So if it absorb water, it will reach 100% to the lab or decreases. Decreases. Sometimes it decreases to 90% because it is highly hygroscopic in nature. Okay. So to prevent this, we add SO3 to H2SO4. This is called fuming of SO3. Fuming of SO3 in H2SO4. Now, what I will prepare, I have prepared 100% H2SO4. This is 100% H2SO4, and in this H2SO4 we have added SO3 in terms of bubbles of SO3. This is called fuming of SO3. Now this is a mixture of H2SO4 and SO3, which is known as oleum. Which is known as oleum. So this is the oleum mixture. Now, as we have prepared 100% H2SO4 and added SO3 gas, if it absorb water now, this SO3 bubble will react with the water and will give H2SO4. इसका मतलब आपने 100% प्योर H2SO4 बनाया, उसमें SO3 फ्यूम की, अब वो रास्ते में जाएगा, वाटर एब्जॉर्ब करेगा, सल्फ्यूरिक एसिड बनेगा. तो रास्ते में भी सल्फ्यूरिक एसिड बनता जाएगा, तो प्योर मिलेगा. तो लेकिन प्रॉब्लम ये है कि इफ यू बाय 100 ग्राम ऑफ H2SO4, 100 ग्राम H2SO4 एंड SO3 मिक्सचर ओलियम, तो आपके तक पहुंचने तक तो उसका वेट बढ़ेगा या कम होगा? हाँ, तो इसीलिए घटेगा कैसे? बढ़ेगा. So now the problem is that if 100 gram H2SO4 increase its weights due to adsorption of H2O, due to adsorption of H2O, तब इस ओलियम की एक परसेंटेज डिफाइंड होती है, ठीक है, एंड दैट परसेंटेज ऑलवेज ग्रेटर देन 100. लेट्स से this is a oleum mixture and the percentage is 110%, and the percentage is 110%. What does it mean? It means if you buy 100 gram oleum mixture, you will get 110 gram H2SO4. Is it clear? If the percentage is 105, that means if you buy 100 gram oleum mixture, the weight of H2SO4 you will get is 105. So let's say this is a oleum mixture and the percentage is 110 and the percentage is 110. You have to calculate the free SO3 present in this oleum. Question hai. You have to calculate free SO3 present in this solution. All other center, post your answer. Presence of free SO3 in oleum mixture having percentage 110. $21. Any other center? What is the free SO3 present in oleum mixture which consists of 110%? The percentage is 110. See, there are two methods to calculate this question. One is H2SO4 plus SO3, the weight is 100 gram. If the percentage is 110, that means H2SO4 form is 110 gram. Okay. From 100 gram of H2SO4 plus SO3, you will produce 110 gram H2SO4. The first method is, let us assume that the weight of SO3 is X and the weight of H2SO4 left is 100 minus X. Okay. So this 100 minus X is not involved in the reaction with water. So the weight of H2SO4 100 minus X will be as it is in this H2SO4 from 110. Okay. Now this SO3 is now form H2SO4 and it added some amount of H2SO4 in 100 minus X value. So can we write this SO3 react with H2O to give H2SO4? If it is X gram, X by 80 is the mole. X by 80 multiplied by 98 is the weight of H2SO4 produced from X by 80 moles of SO3. Okay. Now the total mole of H2SO4, 100 minus X directly from H2SO4 plus 98X by 80 can be written as 110. From this you can able to find the value of X. Clear? So X will directly be the percentage because out of 100 you are getting this X. Clear? The second method is that you see the change in weight. Change in weight is 10 gram. We can able to add the conservation of mass. If 10 gram weight increase, that means water added it will be 10 gram. Additional water will be absorbed by the solution is 10 gram. Then moles of water is 10 by 18. This mole equals to this. So you can able to calculate X by 80 equals to 10 by 18. You will get the value of X. Both are same. Clear? Clear? So SO3 is used for making oleum mixture to protect the H2SO4 from water. Clear? So these are the oxides of sulfur, selenium, right? Now the type of oxide, there are different type of oxides we can able to classify in different modes also, based on the acidic nature, based on the basic nature, based on the type of oxides form. Any metal when reacted with oxygen, it form metal oxide of type M2O, which again treated with O2 to give M2O2, we again treated with O2 to give MO2. I am assuming that our metal is monovalent. That means the oxidation state of metal in all element is +1. Okay. So if it is +1, that means we can able to take that metal as a metal oxide or alkali metal. So this M2O, see this M2O, the metal is in the +1 oxidation state and oxygen in the 2-. Okay. So this is called as metal oxide. In M2O2, the metal is in the +1, whereas the oxygen is -1. So this is a peroxide linkage. Clear? And there are two metal both attached with the -1. In this structure, this is OO. This oxygen consists of one additional electron, therefore -1. This oxygen in the radical form, this is neutral. So entire O2 consists of 1-. Okay, and this is entire O2 consists of 2-, and here one oxygen consists of 2-. So I am increasing the oxygen content and decreasing the individual charge. Okay, if the size of metal are small, it exists in this form. That means if I am talking about lithium, Li2O is the stable form, exists in oxided form. If the size is little bit higher, like sodium, it form in the peroxide form. If the size are much more higher, like KO2, CSO2. So which type of oxide form is depend upon the size of this metal. Higher the size of metal, higher with the oxygen content. Clear? Now, when you add water to this type of metal oxide, acidic water is added, it will give you hydroxide, which are basic in nature. When this hydroxide is treated with carbon dioxide, it will give you metal carbonate, M2CO3. When peroxides are undergo acidic hydrolysis, it will give you MOH plus. This will also give you peroxide, H2O2 and MOH. Clear? So H2O2 can be achieved by treating Na2O2, which is also known as oxone. Clear? So based on the oxides, you first write down. Clear? So based on the type of oxide which we form, these oxides are first classified as a normal oxide, right? It consists of MO bond. They are the very simple H2O, MgO, Al2O3. The second is peroxide. In normal oxide, oxygen always consists of 2-, and in peroxide, oxygen consists of 1-. The most common peroxide is H2O2, hydrogen peroxide. Okay, hydrogen peroxide give oxygen, free oxygen. So H2O2 gives H2O and half O2. Clear? So to deal with the solution concentration, we use a term molarity, normality, mole fraction, formality, right? But in H2O2, especially for H2O2, in industry, they use a new term which is known as volume strength. They use volume strength. Why they are using volume strength? Actually, H2O2 is used, or H2O2 is a very good source of this oxygen. Okay, so in industry, they want some reagent which produce oxygen. Clear? So now, if I will give you two solutions, both consist of hydrogen peroxide. This is also H2O2. this is also H2O2. The molarity of this H2O2 is, let's say, 5 molar. The molarity of this is 7 molar. Through molarity, you can able to get that 5 molar means 5 mole of H2O2 is present in 1 liter of solution. Now, you are going to take H2O2 because they are the source of oxygen. So, from this 5 molarity, you have to calculate that from 1000 ml, there are 5 mole of H2O2. 1 ml, 5 by 1000. This is the mole of H2O2. Then 1 mole will produce half mole. So, this much mole will produce this much oxygen. Then you can able to predict that, okay, this solution, if I take 1 ml, it will give this much of oxygen. Then you have to convert it at STP because there are mole. So this required large number of calculations. Then you can able to get that this H2O2 or this solution will H2O2 give this much of oxygen. Volume strength is a different thing. What volume strength says? If I say, I will write volume strength of this H2O2 is 5 and volume strength of this H2O2 is 10. Okay, let's say volume strength explain karo. Let's say I have written that volume strength of this solution is 5, volume strength of this solution is 10. Now what does it mean 5? That means if this solution you will take 1 ml, if this solution you will take 1 ml, it will give 5 ml oxygen at STP. And if the volume strength of this H2O2 is 10, that means if you take 1 ml of this solution, it will give 10 ml of oxygen at STP. So how you define volume strength? It is the 1 ml H2O2 gives X ml oxygen at STP, then volume strength is X. Then volume strength is X. So it is very easy to calculate the amount of oxygen produced by that particular H2O2. Clear? Clear hai? Now let's say this H2O2 is 5 molar or molarity की जगह अगर normality, let's say the normality of this H2O2 is N. Normality is N. Now I need a relation between volume strength and normality. Calculate the relation between volume strength and volume strength equals to how much normality you have to calculate. Solve. If the volume strength, we have to calculate the volume strength in terms of normality. Assuming that the normality of this solution is N, nothing is given. Now volume strength and normality, there is a relation between volume strength and normality. You have to find the relation between volume strength and, okay, what is the answer? Bolo. Normality upon N factor is molarity, not the volume strength. Other center can also post their answer. What is the relation between volume strength and normality? Let's say the H2O2, the normality is 5 normal, and you have to calculate the volume strength. So what is the factor which is multiplied by normality, and you can able to directly get the volume strength? First, you have to understand the definition of volume strength. 1 ml of H2O2 produce how many ml of oxygen at STP? That is known as volume strength. नहीं हो रहा है? 5.6. 5.6 into normality is volume strength. Clear है? Let's say this is H2O2 and the normality is N. The normality is N. N normality means N equivalent of H2O2 present in 1000 ml solution. We know that H2O2 gives H2O plus half O2. Okay, and we have to calculate 1 ml H2O2 gives how many ml oxygen. This is what we called volume strength, and especially at STP. Okay, can I say if the normality is N, that means N equivalent of H2O2 is present in 1000 ml H2O2 solution. Yes, reverse is also true, so that we can able to write that 1 ml H2O2 solution consists of N by 1000 equivalent H2O2. See the H2O2, the oxidation state is -1, -2 and 0. So the oxidation state of oxygen is changing, and it is a disproportionate reaction. -1 say -2, -1 say 0. When a reaction is disproportionate, we cannot able to use the law of equivalent. So we have to convert this in the mole. So 1 ml H2O2 consists of N by 1000 equivalent of H2O2. Can I write 1 ml H2O2 solution consists of N by 2000 mole of H2O2? The N factor of H2O2 is 2. So N by 2000 moles of H2O2. Okay. So 1 mole H2O2 gives half mole oxygen. That means N by 2000 mole H2O2 will give N by 4000 mole oxygen. Yes. N by 4000 multiplied by 2244 ml O2. 1 ml H2O2 solution will give N by 4000 into 22400 ml oxygen. If you divide this, you will get N into 5.6, which is volume strength. So you can able to calculate the volume strength in terms of normality. Okay. So you can able to calculate the relation between molarity and volume strength. Clear? Clear? Okay, this is the third type of oxide, which is known as suboxide. In the suboxide, the quantity of metal or element is higher. In general, the oxide which we have read so far is oxide, peroxide, superoxides, right? If I am saying that oxide, that means sufficient oxygen. Peroxide means oxygen are higher. Okay, superoxide means oxygen is higher than peroxide. Suboxide means oxygen is less than normal oxides, right? So oxide, number of oxygen are normal. Peroxide, oxygen is higher. Superoxides, oxygen is higher than peroxide. Suboxide, oxygen is less than normal oxide. Say carbon monoxide, CO, one oxygen is the one carbon. But if I make superoxide, there are three alene structure of oxygen. These CCOO. Clear? So these type of oxides, the carbon content is very low. Clear? Yes. So all pi bond are in plane or not in this structure? Plane. There is a structure similar to alene. Alene is optically active. 3 times they have already asked in the JEE mains. The hybridization of carbon is sp. This hybridization is sp. Sp. Clear? What is the shape of sp? How many unhybridized orbital are there? 2. So this carbon is sp. Shape is linear. 2 unhybridized orbital. Yes. Let's say one unhybridized orbital I have made like this in the plane. Yes. And the second unhybridized must be above and below the plane. So the red marker pen is above and below the plane. Simple. See, what is the hybridization of this carbon? Sp. So if this is also sp, this is again carbon and it is linear. Yes. This is linear. One unhybridized is in the plane and other unhybridized in the perfect above and below the plane. So there is a pi bond between this unhybridized. Okay. Pi bond between this unhybridized. Now this is also sp. If I make unhybridized, now this pi bond can form bond with this. Yes. If this is also oxygen, this is also unhybridized, है ना? तो अगर वो इसके साथ तो बना नहीं सकता तो उसको तो प्लेन में आना पड़ेगा, नहीं है? तो ये वाला पाई बॉन्ड इसके साथ बनाएगा. That means all pi bonds are not in the same plane. All pi bonds are not in a same plane. Clear? So this is carbon suboxides. Clear? Nitrogen also forms this type of oxides. So first classification, we have learned about the type of oxides. They are simple oxide, then peroxide, superoxides, and suboxide. They are the nature with respect to oxygen. Now, oxides may be acidic, basic, or neutral, or amphoteric. So based on basic oxide, we are learning first. Basic oxides. Basic oxides are those oxides which give OH minus in aqueous medium or which produces bases. Generally, all the element of alkali metal, like lithium, sodium, potassium, and earth metal, MgO, calcium oxide, right? These are basic oxides. Clear? Why they are basic oxide? See, if these metal oxide M2O is added in water, oxygen consists of 2 minus. and it is strong conjugate base. So this O2 minus react with water to accept one hydrogen and it produce two OH minus. You will say that there is a metal which can form bond with this OH, MOH, but this MOH is 100% soluble in water. Okay, why this is 100% soluble? Because the hydration energy of these metal are very high. Solubility of any hydroxide is defined by two factor. Okay, nahi aaya? Solubility of any hydroxide is defined by two factor. One is hydration energy, other is lattice energy. If hydration energy is higher than lattice energy, that hydroxide will be soluble. So almost all alkali metals, hydroxides are soluble in water and the solubility increases down the group. Solubility increases down the group because lattice energy decreases. So highly basic in nature are cesium hydroxide. So we can say CSOH, then KOH, then NaOH, then LiOH. Clear? T2O3, Bi2O3, THO2. These oxides are also basic, whereas CrO3, CrO2, CrO3, S4O6, these oxides are also basic. Not all oxides upon reaction with water and H plus give hydroxy ion. Some oxides are basic due to their reaction with the acids. If they react with HCl, HBr, they are treated as basic oxides. Clear? Now three more oxides. One is amphoteric, acidic and neutral. Amphoteric oxide, aluminium Al2O3. This is amphoteric oxide because it reacts with HCl as well as NaOH. See the reaction, the oxidation state remain constant. In Al2O3, the oxidation state of aluminium is +3. When it reacts with HCl, it gives +3. When NaOH, it will give +3 because it is acid-base reaction. So amphoteric oxide are the oxide which react with acid as well as base. Acidic oxide almost all non-metal, mainly non-metal oxides are acidic oxide like B2O3. They generally give upon hydrolysis acids. H3BO3. H3BO3 is acid. Why? दे ही नहीं पाएगा. कैसे देगा H3? कोई रेजोनेंस थोड़ी ना O माइनस. If H3BO3 is acidic, then all the hydroxide of boron family must be acidic. If it give H plus, the structure of BOH is like this. BOH, OH, OH. ये H plus कभी निकल सकता है? ये निकलेगा तो ये O minus तो highly unstable है. नहीं है. This is acidic because when this H3BO3 is treated in water, the size of boron is very small and it is electropositive in nature. All oxygen withdraw electron from boron, right? So it is electropositive. So if it is electropositive, the polarization ability of B is very high. So this oxygen, as well as this is a Lewis acid. Lewis, it forms 6 electrons. This oxygen attack to this boron. Now this boron, this oxygen get positive charge. It accept electron and give H plus. So it will become H bore plus H plus. So after reacting with water, it displays H plus from water. That's why it is acidic in nature. But in this family, if you go down the group, the size of central atom increases, the polarization ability decreases. So when water attacks to the central atom, the polarization ability decreases, it displays OH minus and they will become basic. So H3BO3 is or B2O3 is acidic only because the size of boron is very small and the polarization is very high. It can able to generate H plus. But if the size increases, it will displace OH minus. Neutral, you always know that neutral are only 1 or 2 nitrogen and carbon. Okay. Clear? These structure we have already completed. Selenium structure, sulfur. So let's start with the compounds of oxygen family. Some of the compound chemical properties as well as physical property you have to learn. In between that, oxygen, ozone, sulfur, H2SO4, H2SO3, H2S gas, H2O2. These are the compound of oxygen family which you have to learn. All the reaction preparation property. Okay. First is oxygen. So preparation of oxygen, we have written the thermal preparation. Okay. These are the four very basic preparation of oxygen. First one is HGO. See, mercury, the oxidation state is +2 and oxygen is -2. It is self-reduced and converted to Hg and O2 is formed. So mercury oxide, from mercury oxide, preparation of oxygen is a very good method. Similarly, we have written all the oxides. See, upon thermal decomposition means we have heated these oxides. So preparation of oxygen, oxygen is prepared only from the, or you can say good source from the oxides, because oxides are easily available. Mercury oxide is easily available, silver oxide is easily available, MnO2 is easily available. Upon acidic hydrolysis, they will produce certain other element, but thermal decomposition, they will produce metal as well as free oxygen. So this is the first method of preparing oxygen from metal oxide. Okay, this is simple thermal, or we are heating these oxides at elevated temperature to produce oxygen. This is the second method on which we are producing oxygen from the oxide, which consists of higher number of oxygen like KNO3. KNO3 when heated, it gives KNO2 plus O2. K2Cr2O7 when heated, it gives K2Cr O4Cr2O3 and oxygen. Almost all. Why we have written rich salt? Because all consist of very huge amount of oxygen as compared to the last. Okay, so these are the very good source of O2. KClO3, KCl plus oxygen. What is the N factor of KClO3 in this reaction? Fourth reaction. Fourth reaction. KClO3 give KCl plus oxygen. What is the N factor of KClO3? This reaction, what happened? If you see the chlorine, it is the oxidation state of chlorine is +5. नहीं है +5. 3 to 6, 1 +5. Oxidation of chlorine is -1. So +5 to -1, chlorine accepting 6 electron, whereas oxygen -2 to 0, it lost 6 electron. So this is a reaction in which chlorine was gaining 6 electron and oxygen lost 6 electron. So gain 6, lost 6, so the N factor will be 6. If both gain 6 electron, N factor will be 12. Okay, so these is perfectly a redox reaction, self-redox reaction in which chlorine accept the electron and oxygen lose the electron. Okay. Second thing is that these are the method of preparation of oxygen when we are heating, simply heating these oxides. Okay. Second is the reaction with H2SO4, and again these reactions are also take place in approximately temperature 140, 160 degree. See, MnO2 itself give with H2SO4 give oxygen with MnSO4. In acidic medium, Mn always go to +2 oxidation state, irrespective of the oxidation state which is present. If the acidic medium, it will undergo +2 from +4 to +2 and produce oxygen. Similarly, potassium permanganate again Mn +2. Okay, K2Cr2O7 acidic medium goes to +3 and give oxygen. So KMnO4, K2Cr2O7 are the good source of oxygen. So we can able to produce oxygen from permanganate and dichromate by treating H2SO4 with these molecules, right? Ozone. The reaction of ozone can be prepared from oxygen. Ozone can be prepared from oxygen. See, oxygen gives ozone. Preparation of ozone from oxygen needs some ozonizer. Let I ask you one question. Let's say this is the ozonizer. हमने यहाँ से oxygen दी, and this oxygen is 100 moles. 100 moles. Sorry, 1000 moles. And it give oxygen and ozone, mixture of oxygen and, if the mixture of oxygen and ozone and 888 mole, then what is the mole of ozone and oxygen? Clear? 1000 moles of oxygen is passed through a ozonizer, and this oxygen is converted to oxygen and ozone. Mixture of oxygen and ozone are 888 moles. Then find number of moles of oxygen present in the mixture. Calculate. इसके बाद क्या करना है? ऑक्सीजन के बाद क्या करना है? अभी बता दो, फिर मैं टॉपिक मिलेगा. अच्छा, ऊपर से बताएंगे. जल्दी छोड़ना क्लास. ये तो मैं ऑक्सीजन की बात कर रहा हूँ, इसलिए कह रहा हूँ हो जाएगा 5 मिनट में. I think it is 400 something. See, oxygen is ozone is converted to oxygen. Yes, you have to balance the reaction, and we know that almost some oxygen left and some part of oxygen is converted to ozone. So let's say out of 1000 mole, X mole of oxygen is converted to ozone. Out of 1000, this is total number of moles, 1000. From 1000, X mole is converted to ozone. So the ozone form will be 3x by 2. Can I write 1000 minus x plus 3x by 2 equal to 888? We can get the value of x. दो तरीके हैं, एक तो ऐसे कर लो, दूसरा कंजर्वेशन ऑफ एटम यूज करो. We have added 1000 n into 2 number of atoms. तो मिक्सचर में भी 1000 n into 2 ही ऑक्सीजन के होंगे. If this is x, this is 888 minus x. X n 888 minus x into 3n must be equal to 1000 n into 2. Number of atom will be conserved. बैलेंस तो कर ही लोगे. ठीक है, क्लियर? मिटाओ. See, all the oxidation as well as reduction property of ozone is due to this reaction. It gives O2 and nascent oxygen. It gives nascent oxygen. This nascent oxygen is responsible for almost all oxidation. For example, when it's treated with PBS as written in this reaction, this PBS react with this nascent oxygen. Now, sulfur, the oxidation is -2. It accepts this oxygen and convert it to SO4 2 minus plus Pb2 plus. We know that PbSO4 is not soluble, so PbSO4 get precipitated out, isn't it? So right, see this reaction. Ozone gives nascent oxygen. Ozone gave nascent oxygen, and this nascent oxygen is treated with PBS. है ना? Actually यहाँ O3 लिखा है, ये react कर रहा होगा O के साथ. तो this O convert this sulfur to PbSO4. Similar kind of reaction with Ki, HCl, and K4FeCN whole 4. In this, you can able to see that the iron is +2 oxidation state. Here, the iron is in the +3 oxidation state. K4 से K3 हो गया ना? Clear? So, reducing property, reducing are always related with the oxygen atom. H2O2 -1 से -2 जाएगा. Similarly, BaO2, BaO2 में O2 में -2 है, तो -1 हुआ एक ऑक्सीजन. Peroxy linkage है ना ये? So it is converted to O2. Clear? So ozone, oxidation and reducing nature. You have to learn all these reactions also, right? So what is the structure of ozone? This is O double bond O, O minus, which undergo clear? The most common reaction of ozone are with the hydrocarbon. Alkene का reaction याद है ozone के साथ? Yes. hydrocarbon react with ozone. This structure is responsible for the reaction of hydrocarbon, isn't it? So the reaction of ozone with hydrocarbon, let's say this is alkene and this is a positive and negative charge which approaches, electrophile approaches this carbon. So this carbon get negative, this carbon get negative, this positive, negative, positive, negative, positive, form a 5-member ring. This 5-member ring is known as monoxide. This 5-member ring is known as monoxide, which is highly unstable due to the presence of large number of lone pair. Due to the presence of large number of lone pair. So this monoxide undergo rearrangement. This monoxide undergo rearrangement. See, these two double bond come to this point and these two electron to this oxygen. Now this is converted to CH3 C double bond O H plus CH2 OO minus. Clear? First alkene undergo addition with ozone to give monoxide. This monoxide will give 1,3 dipolar and a carbonyl compound. In one time JEE, in the question of JEE, they asked that ozonolysis is not carried out in acetonic medium. Why? Because monoxide is first converted to carbonyl compound and 1,3 dipolar ion. This 1,3 dipolar ion attack to this carbonyl compound. If the medium is acetonic, this 1,3 can attack to that carbonyl also. So you will get mixture of ozonides, right? And that mixture of ozonide will give different type of products. Now this 1,3 dipolar ion now approach to this carbonyl compound. This oxygen attack to this carbon, both the electron, oxygen plus and this oxygen minus, can form a ring where the lone pair repulsion will be relatively less as compared to the last. Clear? इस नेगेटिव चार्ज का अटैक इस कार्बन पे हो रहा है, ये दोनों इलेक्ट्रॉन इस ऑक्सीजन पे आ गए, इस ऑक्सीजन का नेगेटिव और इस कार्बन का पॉजिटिव बॉन्ड बना. देखो ये क्या था, मोनोजाइड. दिस इज अनस्टेबल ड्यू टू द प्रेजेंस ऑफ 3 oxygen. Monoxide is rearranged to give carbonyl and 1,3 dipolar. This 1,3 dipolar react with this carbonyl to give ozonide. Ozonide is relatively more stable as compared to monoxide. Now this ozonide will give different product depending upon the type of ozonolysis. Mild oxidative, oxidative and reductive. 3 type of ozonolysis are there. One in presence of H2O2, other in presence of water, third is in presence of lithium aluminum hydride. Clear? Clear? After ozone, let's discuss the stability of halides All these elements form halide, and the most stable halide are fluoride. Fluoride are most stable, size factor. The bond length will less and form more exothermic bonds. So fluoride, chloride, bromide, and iodide. Sulfur, selenium, these we have already discussed the hybridization structure of these halides. Okay, among all halides, the most stable is fluoride, and last one is iodide. And all compounds can form halogens to form hexafluorides also. And a type of halogens and halides we have already discussed. Oxygen कौन सा बना रहा था? Chlorine है ना? Next. Now, oxo acids of sulfur. The most common oxo acid is H2SO4. Apart from H2SO4, sulfuric, peroxy, and sulfurous. These are the weaker acid, but the most acidic is H2SO4. Sulfuric acid. Clear? Sulfuric acid is used in double titration as well as single titration. Double titration और single titration दोनों में हम sulfuric acid को use करेंगे. Clear है? Double titration में क्या किस में use करते हैं sulfuric acid? NaOH and Na2CO3 याद है? NaOH and Na2CO3 is present in a solution. Okay? And we are titrating this solution with H2SO4 having normality N. Any normality, given normality, 1 normal, 2 normal, 3 normal. See, sulfuric acid is the most acidic among all oxo acids, and the main reaction as well as use of sulfuric acid is the use in the double titration. ठीक है? How you define double titration? See, let's say this is a solution and it consists of sodium hydroxide, and we know that sodium hydroxide and H2SO4 react to form Na2SO4. Now, the volume is 200 ml. How many ml? We have used as an indicator. In this, we use an indicator and titrate this solution with H2SO4. With H2SO4, 1 normal. 1 normal. When dropwise drop H2SO4 is added in NaOH, this NaOH is consumed, right? When the NaOH is completely consumed, the pH of solution become 7. Solution का pH 7 होगा. 7 के होते ही इंडिकेटर चेंज हो जाएगा. कैसे चेंज होता है इंडिकेटर? कलर. इंडिकेटर का कलर ही तो चेंज होता है. कलर कैसे चेंज होता है? See, before reading these double single titration and the reaction of sulfuric acid, you must understand the indicator use also. ठीक है? क्या मैं इंडिकेटर छोड़ रहा हूँ? तो NaOH तुमने लिया, जब H2SO4 तुम ऐड करोगे ड्रॉप वाइज ड्रॉप, जिस पॉइंट पे NaOH खत्म होगा उस समय इंडिकेटर आपको बताएगा कि NaOH कंप्लीट हो गया है. You stop the adding H2SO4. Okay? Let us assume that 170 ml H2SO4 is added for the complete titration of this NaOH. So how many milli equivalent of H2SO4 added? 170. So milli equivalent of NaOH left is 170. So we can able to calculate exact weight of NaOH present in the solution. Now, if a solution consists of 2 bases, NaOH and Na2CO3, and we are titrating this base with this H2SO4. So see, H2SO4 first react with NaOH. When NaOH is completely consumed, then Na2CO3 start reacting with H2SO4. If I use same indicator in this solution also, we can able to get the volume of H2SO4 required for the complete titration of these two. समझ आया तुम्हें ये? Clear है? Now, let's say there is an indicator INOH which form an equilibrium with IN plus and OH minus. IN plus and OH minus. ठीक से सुनना. देखो, this IN minus is red in color, whereas INOH is colorless. ठीक? ये कैसा कलर का है? ये कलरलेस है. नाउ कोई भी कलर तुम्हें तब दिखता है जब आपका एक सर्टेन इंटेंसिटी को क्रॉस करता है. If you add 1 drop of ink in 1 liter of water, blue color is not visible. Same 1 drop of ink, if added in 1 glass of water, the blue color is visible. So we have fixed the ratio. Let's say the ratio of IN plus upon HIN indicator is 10. When the ratio is 10, the red color is visible to you. The equilibrium constant of this reaction Kc, let's say 10 to the power minus 6. 10 to the power minus 6. तो अगर ये 10 to the power minus 6 है तो ये रिएक्शन फॉरवर्ड है या बैकवर्ड है? बैकवर्ड है. तो IN माइनस की कंसंट्रेशन तो बहुत कम होगी, HIN बहुत ज्यादा होगा, तो क्या ये रेशियो 10 होगा? नहीं होगा. तो अब इस HIN को NaOH के सॉल्यूशन में ऐड कर दो. पहले से OH माइनस थे. This OH minus due to common ion, this reaction goes backward direction, and this ratio is less than 10, and the solution is colorless. Clear? Now what happened when you add H plus, OH minus will be consumed, and this reaction goes forward direction, and the concentration of iron minus, that means there will be a time when this ratio goes forward and strike to the 10 and reach the end point. We have to calculate at what ratio this end point will reach. Can we write IN plus into OH minus by INOH is actually Kc? Can we write OH minus can be written as Kc INOH by IN plus? I have multiplied both side minus log. This can be written as POH minus log of Kc can be written as PKc plus log IN plus by INOH. Yes. If the PKc value is 10 to the power minus 6, that means PKc is 6. At what concentration ratio you can able to see the red color? Can I say log 10 is 1, 6 plus 1 is pH equals to 7. That means at 7, the ratio strike to 10 and the red color is visible to us. And at pH 10, pH 7, the NaOH present in this solution are completely consumed. Clear? So by this way, these indicator behaves. Is it clear? So we are talking about the double titration of NaOH and Na2CO3 in which the indicator play a very important role. ठीक है? देखो, अगर मेरे को सिर्फ NaOH को titrate करना तो we can able to use H2SO4 with any indicator. Milli equivalent of H2SO4 can be equal to milli equivalent of NaOH, and we can able to find the value of milli equivalent of NaOH. In double titration, we have added NaOH and Na2CO3. Clear? Now, see the double titration role. In this container, I have added 2 indicators. One is methyl orange. Methyl orange changes the pH when the pH is between 6 to 6.5, 5.5 to 6.5 kind of thing, right? Second is phenolphthalein. Phenolphthalein is an indicator which change color 8.5 to 9.5. Okay. This solution consists of how many bases? 2, NaOH and both NaOH. Due to presence of both NaOH, the pH of this solution become approximately 13 or 14, highly basic in nature. And phenolphthalein will show change in color at pH 9.5. So at this moment, when the titration is not started, is it possible that this solution change its color? No. So this solution is colorless. Now H2SO4 which react with both the acid. First, stronger acid. So in the step 1, NaOH will react with H2SO4. NaOH plus H2SO4 give Na2SO4 and H2O. Second step, second reaction, Na2CO3 react with H2SO4 to give NaHCO3 plus Na2SO4. Third step, NaHCO3 react with H2SO4 to give H2CO3. Clear? See, when you add H2SO4 to this solution, first NaOH react, the pH is initially 13. When NaOH is completely consumed, the pH is approximately reached to the value of 10. But this indicator phenolphthalein will show color change in 9.5. When NaOH is completely consumed, the pH strike to 10.5, or it might possible 11, depending upon the concentration of Na2CO3 also. But when NaOH is completely consumed, it will not strike the range of phenolphthalein. So the color is still colorless. So we cannot able to check whether the NaOH is completely consumed or not. But it is completely consumed. So still we are adding NaOH. Now the second H2SO4 now react with Na2CO3. When Na2CO3 is completely converted to NaHCO3, the pH of solution strike to the phenolphthalein endpoint, 9.5. Clear? And phenolphthalein change its color. So I stop adding sulfuric acid to the solution. Can I say at this moment, milli equivalent of H2SO4, which is consumed in endpoint of phenolphthalein, is equals to milli equivalent of this NaOH plus milli equivalent of this Na2CO3. So I will write first endpoint. First endpoint. This first endpoint is due to phenolphthalein. Can I write milli equivalent of H2SO4 equals to milli equivalent of NaOH plus milli equivalent of Na2CO3. Here the N factor of NaOH is 1 and Na2CO3 is 1 because it accepts 1H plus, right? So in the second endpoint, now after noting the value of milli equivalent of H2SO4, we'll again start adding H2SO4. Now the H2SO4 will react with NaHSO3. Now this solution color is red because 9.5 is pH. When you add sulfuric acid, it decreases from 8.5, the solution become colorless. Is it clear? So in the colorless solution, when you add sulfuric acid, NaHCO3 will react. When H2CO3 form, the solution pH is less than 7 acidic and phenolphthalein change its color. So this is called second endpoint. So in the second endpoint, can I write milli equivalent of H2SO4 equals to milli equivalent of NaHCO3? Clear? So milli equivalent of NaHCO3, we can able to calculate this value. We can able to put Na2CO3 here. These NaHCO3 and Na2CO3 are equal. So we can able to get the value of NaOH. Clear? So sulfuric acid, the first application is the volumetric titration. The first application of H2SO4 is volumetric titration. Volumetric titration simple as well as double titration. This titration is clear. Should I ask a question? Okay. Madam? Let us assume that a container consists of base NaOH 1 gram, Na2CO3 1 gram, and NaHCO3 1 gram. And the volume of this solution is 1 liter. Okay. We are going to titrate this solution with H2SO4. Normality of H2SO4 is 1 normal. Normality of H2SO4 is, okay. So the question is of 3 part. Let's say I have taken 3 solution. This is a 1 liter solution. 1 liter solution, I have taken 250 ml, 250 ml, 250 ml. All 3. Clear? In the first, I have added phenolphthalein, only phenolphthalein as an indicator. Second container, only methyl orange as a indicator. And third container is first titrated using phenolphthalein. After that, methyl orange is added. Okay. So the volume of H2SO4 required in these V1, V2, V3. You have to calculate the volume of H2SO4 required in V1, V2, and V3. Other center can post their answer if they can able to calculate the V1, V2, V3. हो गया? See, in the first we'll give color change in the presence of phenolphthalein. Okay, phenolphthalein change its color when the pH is approximately 9.5. So NaOH will completely react in presence of phenolphthalein. Yes, in the first case, NaOH react with H2SO4 to give Na2SO4 plus water. Secondly, this Na2CO3 also react with H2SO4 to give NaHCO3, right? So I can say milli equivalent of H2SO4 equals to milli equivalent of NaOH plus milli equivalent of, perfect. Now milli equivalent of H2SO4 is 1 multiplied by V1. But I have told that the volume of this solution is 250 ml and this 1 gram is present in 1 liter. So in this solution, it must be present 1 by 4 gram. So this milli equivalent of NaOH can be written as 0.25 gram by 40 NaOH molecular mass multiplied by 1 into 1000 milli equivalent plus 0.25 by Na2CO3 multiplied by 1 multiplied by 1000. Is it clear? So from this equation, we can able to calculate the value of V1. Yes. So this is the first part, V1. Is it clear? लिख लिया बेटा? So to calculate V2, see in V2 we have used methyl orange. So methyl orange will change the color when the pH is acidic, and the pH will be acidic only when all three bases will react. In methyl orange, the N factor of Na2CO3 will be 2 because it is converted to H2CO3. But when we have used phenolphthalein, the N factor of Na2CO3 is 1 because it is converted to NaHCO3. Simple. So with respect to methyl orange, the calculation will be this is converted to H2CO3, and third NaHCO3 is also converted to H2CO3. Now we can say V2 into 1 equals to 0.25 by NaOH into 1 into 1000, 0.25 divided by Na2CO3 into 2 into 1000 plus 0.25 by NaHCO3 into 1 into 1000. You can able to calculate the value of V2. V1, V2, both. Clear? When methyl orange is used, the color will change when all bases will react completely. If there is Na2CO3, it is converted to H2CO3. How many H plus it will absorb? 2. So the N factor will be 2. When you are using phenolphthalein, this Na2CO3 is converted to NaHO. The N factor is 1. Clear? Clear? So in the third equation, see, third equation is titrated when this NaOH is completely consumed, so it is not present there. this Na2CO3 is now converted to NaHCO3. Is it clear? So in the third case, can I say there is only one reaction, that is NaHCO3 जो इससे बना था और NaHCO3 जो पहले से था, यही दो react करेंगे. So the equation will be like this. NaHCO3 milli equivalent of NaHCO3 plus milli equivalent of NaHCO3 equal to milli equivalent of H2SO4. This milli equivalent of NaHCO3 is 0.25 by NaHCO3 into 1 into 1000. Whereas this milli equivalent of NaHCO3 can be written as 0.25 by Na2CO3 into 1 into 1000. Why I have written Na2CO3? I have calculated the milli equivalent of Na2CO3. The milli equivalent of Na2CO3 can be equal to milli equivalent of NaHCO3. So from this, I have calculated this. That's why it is written as Na2CO3 into 1000 can be written as V3 multiplied by 1. Now V3 can also be calculated. Simple. So V1, V2, V3. Next. Okay. Down. See, sulfuric acid, we have done two things. One, oleum strength, and second is double titration with sulfuric acid, right? So now, how to prepare this H2SO4? Manufacturing of sulfuric acid, right? So there are large number of method of preparation which you have already done in the lab. Also, production of SO2. Sulfur dioxide can be obtained from iron pyrite. If you have learned the metallurgy part, iron pyrite, you can able to prepare SO2. Second, the catalytic hydrolation is converted to SO3. Catalytic hydroxidation, SO2 is treated with oxygen to give, which is upon acidic hydrolysis, H2O in presence of H plus, you can able to prepare H2SO4. Is it clear? So these are the general method of preparation you have to learn. V2O5 is the most acceptable surface catalyst for dehydration of H2SO4, right? You can download this now. So chemical property, first chemical property is simple. With NaOH, H2SO4, it is mentioned that NaHSO4, it is only possible when this NaOH is a limiting reagent, right? Unless first reaction, if this NaHSO4 again react with this NaOH to give Na2SO4. Now, sulfite ion, BaCl2 with H2SO4, this is a displacement reaction. Chlorine is displaced by sulfate. BaCl2 with H2SO4 give BaSO4, whereas lead tetraacetate diacetate with H2SO4, lead sulfate, black precipitate, and acetic acid. Okay. Affinity with water and cleaning property of oxidation. H2SO4 carbon. This is the most common reaction of carbon also. Sulfuric acid ke saath reaction. SO2 water and carbon dioxide. With P4 red phosphorus. It gives H3PO4. Red phosphorus is vigorously react with H2SO4. Large quantity of H2SO4 is added in red phosphorus. Okay. It will give H3PO4, right? H2SO4 react also with H2S to give sulfur precipitate with along with SO2. With HBr bromine gas release, with NaBr also bromine gas release. Clear? Clear? With bromine, Br minus to 0 and sulfur plus 6, it gain to plus 4. So this is a redox reaction. So it can able to displace bromine from HBr and NaBr, and it act as a reducing agent. Clear? It accept the electron. Any doubt? With HBr and sulfuric acid, HBr में bromine की oxidation -1 है when it is treated with H2SO4. it is converted to Br2, -1 to 0, it loses 1 electron, and sulfur +6 to SO2 +4, along with the formation of these byproducts. Clear? Na2S2O3. The most important reaction of Na2S2O3 is reaction with iodine. Thiosulfate and iodine. This is known as iodometry. Used in the titration of knowing the value of iodine. Chlorine and iodine reaction are different. You can able to see that. Iodine is most common and chlorine is asked in last year. See. Iodine react with Na2S2O3 to give NaI and Na2S4O6. Sodium thiosulfate reaction, right? Here, the oxidation state of iodine is 0 and -1. It accepts electron. Sulfur, you can see +2, +2.5, +2 to +2.5. How many electron it accept? 0.5. So the n factor of this is 1. N factor of this is 2. N factor of iodine is 2. Clear? So if a solution consists of iodine, you can able to calculate the exact weight of iodine with the titration of this thiosulfate. Okay? For example, if this container consists of iodine, we titrate this iodine with Na2S2O3. Simple. But the only problem is that thiosulfate react only with iodine. So this reaction is used to calculate the weight of I2. सिंपल है, लेकिन इनडायरेक्ट आइडोमेट्री हम बहुत सारा कर लेते हैं. कैसे? मान लो हमारे पास एक सॉल्यूशन है जिसमें Cu2+ आयन है. क्लियर? एंड वी आर गोइंग टू टाइट्रेट दिस विद Na2S2O3. So we know that Na2S2O3 will not react with Cu2+, isn't it? So what will we do? We add Ki, excess of Ki. है ना? The excess of Ki के डालते ही Cu2+ and Ki react to form I2. Let's say I2 is produced and form in this reaction, and I2 reacts with this thiosulfate. If 40 milliequivalent of Na2S2O3 is required, that means I2 present is 40, then Cu2 present is 40. So we can able to use indirect ideometry. Clear? So these two reactions are again very important. Rest all reaction you have to learn. Clear? Any doubt? So apart from these reaction, complete this oxygen family with NCRT also. ठीक है? Okay.